Oh, excuse me. All right. Hello and welcome to the Friday Community Chill Sesh. Just trying to clear my throat there, but I realized my mic was unmuted, so now the show starts right now. All right, here we go. We'll see what the lads and ladettes are up
You
to
already have
tonight.
faith, or there's a God and on all that. That it really, well, it doesn't really matter. But to me, you can't pick out anything else in life and say, what does it matter if they're lying to me? You wouldn't do that with relationship, right? If your spouse has been lying to you about who they are all their life, are you going to turn around and say, well, what does it really matter?
Dish, if it's a
Okay,
round
so if you're
globe, if
married
it's
to
flat
somebody
Earth.
and you don't know who they are because they've lied to you all their life, what does it matter? You're married, you're there, you're
No, it's already
together.
happening in real time. So I totally get it. It totally matters because it's like it's an immediate reality. But whether or not he's lying to me on a flat Earth or a round globe, um, he's still lying. Like that's way more impactful than me being on a petri dish in God's microscope. Like a slide. Like, because that's like to me how I feel, anyways. It's like God is so great, and the fact that I'm even on this petri slide, which that to me is like I could see the firmament in that, like just because we're small, and he's
What do you think? You're
great.
some sort of
But
bacteria?
I think it's just a matter of I mean, what your example is, like, no, that impacts my like daily existence right now. All I know is my feet are on the ground. I can go out in my bare feet and walk on the earth. If this earth is flat and I'm walking on it and I'm with the Lord, okay. If it's round and I'm still with the Lord. But I understand, like, you're trying, like, people operate on a different level of what they need, and I can understand why you would, press the issue. I
Well, if I can
appreciate
jump in
you
real
letting
quick,
me ask the question.
let me
But
jump
I
in. Real,
don't get your analogy from if my husband's lying to me. Like, yeah, that lies matter, of course. Like, and being deceived, if they have the information and they're not giving to us, that's powers and principalities. That doesn't surprise me because that's been going on forever. So I'll leave it there.
well, I think you're kind of missing the point of what Ken was saying a little bit. So let me try to say it like in a different context, right? Pew Research does a lot of research on
And they're not giving to us.
Christians
That's
and
powers and
things like that,
principalities.
right?
That doesn't surprise
And
me because that's
they
been
did a
going on.
study on
Demographics.
right.
Demographics.
They did a study on Christians who no longer believe in God and no longer go to church. Um, oh, she left. Well, I'll still throw the sauce out for you guys. And they found that 63% of people who were Christian growing up their whole life that decided that they were no longer going to go to church cited science, evolution, and the globe as the reason why they are no longer Christian. Oh, I'm glad she came back. I'll repeat it. Are you there, Power?
Yeah, she was just down in listener.
She disappeared off the screen for me. Are you there, Power?
I'm here. Sometimes I say stuff and then I can't hear a response, so I have to leave and come back.
Okay, well, I'll repeat what I said. I didn't get very far. I saw you disappear on my screen. So, Pew Research is a company that does statistics and research, and I don't remember the words you said, demographics for Christian purposes, right? They did a study on Christians who stopped going to church um, and stopped believing in God. And they found that 63% of people who stopped going to church and stopped believing in God cited science things, right? So, globe, evolution, the Big Bang, they cited these things as the reason why they no longer go to church and believe in God, because the Big Bang tells us, and science tells us that this is true. That long ago, 13.5 billion years ago, there was nothing. And it all of a sudden exploded and became everything. And then over thousands of years through evolution, we became this spinny space ball with people living on it, right? Digging up dinosaur bones and all of these things. Um, and there's no way that there could be a God if the Big Bang happened, right? And if you ask a scientist how evolution happened, they say, well, we have no clue how it happened. But the most logical explanation is that over billions of years, single celled organisms evolved on the backs of crystals, and they discovered how they could reproduce, and they made babies, and those babies evolved into bigger creatures, which evolved into, all these other things. Um, and you're a Christian, and a lot of Christians, to me, ignorantly try to wrap the Bible around what they're told in school, and they're taught and they learn. Right? There's a lot of teachers who will say things when they're teaching the Big Bang in Christian schools, and they'll say things like, "Well, God used the Big Bang." I had a debate with this guy at church because he found out I was a flat earther, and he said that the Big Bang is perfectly in line with the Bible. That when it says one day, it doesn't really mean one day. It could have been millions and billions of years, and that God did everything through the Big Bang and evolution, and we evolved, but God, guided that evolutionary process. Well, that doesn't link us to our Creator at all. We'd have no ties to Him that way. Think about it. If we just evolved, well, that means we could de-evolve, right? We would not be the created. He created this whole world just for us, right? And you said you're a Christian, you believe in God. So if there is a God, then there needs to be an antithesis of God, right? Something that's against God, something that goes against him, right? And don't you think that if we did live, and I always say the fish tank because it's an easy way to think about it. We live in a fish tank. There's a lid, there's walls, right? We can only go so far inside this fish tank. Don't you think that if we lived in something like that, to hide the tank from the fish, you would be, hiding that fish's reality? And that's to us, right? We live somewhere and no one knows what it is, right? We're all told that it's something else. It's this
Yo, you're actually
planet.
making me about to change to everything came from nothing.
Well, that's fantastic.
Big Bang by Jesuit priest for me too now. Is that not what you're selling?
Like it sounds so appealing sometimes, We just came from nothing. Like it's philosophically bankrupt, intellectually bankrupt, but no one's ever seen it, but it's the fundamental backbone of their starting position. How crazy is that? Like your backbone's just like
Yeah, it's kind of like what? Look, shut your eyes so you can't see. It's like
Well, the funny
shut
thing
one
is,
eye while I lie to you, or kind
it's
of
like
tell you a
poof.
story.
You see, the funny thing is, Christians believe that we were created by God and that when we die, we get merged back with our Creator. And evolutionists believe that we evolved from nothing, and that when we die, we go back and merge with our Creator, nothing, right?
a
So
big
it's
part of subverting Christianity was pushing the globe, heliocentrism, and Newtonian physics as like physical descriptions, like merging the heavens to reality. I actually just came across this thing about the Buddhist teachings in Japan from the mid to late 1800s. These guys were geocentric flat earthers. You guys know how we're always told there's no such thing as a geocentric and flat earth, that there's two, it must be a geocentric globe. Oh, word. Crack open a history book, my boy. I can give you guys the citations here in a second. But check this out. These guys were all geocentric flat earthers. And when the Jesuit Christians came to Japan, they pushed their solar calendar, heliocentrism, and that the earth is a globe. And they did it under the guise of Newtonian dynamics, describing the heavens, because that gives physical attributes to them. And it's under the guise of physics, right? Because they're like, well, how could we predict where it's going to be and navigate based on our latitude longitude model and all this stuff? Like it's all intertwined in the way that they pushed it to try to get where we're at now, because they merged the heavens into physicality, and that's not even a real thing. So we're at like the maximum standstill, where they're like, yeah, dude, we're now measuring protons underneath the earth because we know it's definitely a globe. Like,
What
dude,
did they have? Didn't you say they also had some device they used?
It's neutrinos, spaceware.
oh, was it?
They
Thank you.
got busted. They got busted because optics worked contra, like against them. The optics, guys. Our eyes are fucking like a little bit of a globe, and they got tricked.
That's exactly what the Buddhist monks were arguing, because they were using all their perspective teachings against them, because their argument basically was that the physical world around us that we interact with is kind of an illusion, and the true heavens, is obscured to us, and what we see is apparent. So they were using all of these diagrams that they were presenting about, like refraction, Snell's law, how things are optically displaced, how big things can appear small things big, relative to different aspects of perspective, how you can invert things, parabolic flips and all that. And they were like, but you're going to tell us that because you could calculate this planet or whatever you think it is, is going in a circle, that you're describing reality. And it's a real shame that they ended up, losing the battle. But what had happened is that the Meijing dynasty accepted the solar calendar, and it makes sense of that bad boy. You have to become a heliocentric glober. So they were they were locked in, and they made it, get this, lads, they outlawed classic Buddhist flat earth geocentric teachings for like 10 years before they lifted it.
And
so
I was listening to you in I think it was Ether Cos over there, and I think you said something about they were Walter Bislin before Walter Bislin was Walter Bislin.
Oh, dude. So get this, man. When the Jezzies came pushing all this stuff, your boy went to work and he went into like solitude meditation for 13 years, came out of hibernation with the instant divine inspiration with a diagram to make a flat earth geocentric model to represent what their belief system work is, and how it's equivalent to what the Jesuits were pushing in terms of a globe, because they were all using the celestial sphere model, but they were only using the top hemisphere that you could see. They all knew that when a star wasn't visible to you, it wasn't underneath your feet, it was just out of view to you. So what these guys did is they came up with a celestial sphere model that intersects with a terrestrial equator, and so it's like a disc with little hemisphere domes on it, and then there's a central axis. That axis also represents Mount Meru for them and their cosmology. So Mount Meru going up to the heavens, and then on the top there's another disc, and that disc is a flat, it's a flat disc of the heavens, and there's little balls on it that represent the sun, the moon, and different stars. And when you crank the wheel thing, it spins around the axis, and in the hemispherical domes, you'll see the stars and planets, you'll see the sun and stars and moon all move like relative to the latitude when the thing goes up and down in elevation on the axis. And I had ChatGPT translate different words on the diagram, not even showing it the full diagram, but just showing it what the words were, because it's in Japanese. And then they had a hemisphere, they had a North Pole, South Pole. They knew about all these things, and they were geocentric flat earthers. And then and so all of Asian culture, so the Shintoists, China, like they were
But
all
guys,
on the same thing.
hey, bro,
Yeah,
but
go
hey,
ahead.
it's
Go ahead.
Peter, it's Peter Petraki Serigaki a flat earther now? Peter, are you a flat earther?
Who cares, dude?
Yeah,
I am, but
anyway.
nobody cares.
Let
Yeah.
Alan
Nobody
finish.
cares.
Yeah. Yo, Peter, shout out to you, man. Thanks for the support. Much appreciated.
Hey, thank you. Thank you for giving me the membership. And my son is wearing the Aether Cosmology baseball cap right now. And we're going to Europe tomorrow. We're going to wear it in Czech Republic and Denmark. Denmark's first, right? Copenhagen tomorrow, Aether Cosmology.
You
We're
might get a
coming.
warm reception over there, actually.
Nice.
Much
That's
warmer
what's
Yeah,
up.
but you
Yeah,
guys
dude.
have a following. He was telling me the Czech Either Cause website is down because we're going to Prague first week of August. So we wanna meet the lads over there.
Oh, yeah. You can message Dom on Twitter. No
Yeah,
globe
but the
Dom.
website's down. Maybe
No,
they didn't pay the
I mean, you could just message him on
monthly.
Twitter though. They have meetups all the time.
Nice.
But yeah, anyway, the Japanese lads, all geocentric flat earthers, this dude built a working model that represents latitude dependent observations of the stars with an azimuthal grid, essentially, right? And they had 4 different azigrids positioned on the disk. So one, essentially northeast, southwest, you can think of it that way. And then their conceptualization of it was that each continent had their own dome that obscured the heavens and gave it those apparent positions for the seasons and all that. And that's exactly like, so instead of having it be over the whole continent, it's just based off of, what you observe as the observer, but like literally the exact same equivalence, because it's just kinematics, which what we've been arguing. So they all understood that just because the Royal Society came to them and said, hey, we're now mapping stars to negative coordinates because we live on a globe. They were like, oh, did you know that's equivalent to what we were doing? And like, it's just out of our vision. Little history lesson for the boys.
So they figured it out before everyone on the internet just chanted that, where is it? Where is it beneath your feet? Where does it go? What is it doing? What is it?
Yeah, and
Because they knew.
also you can go into Stellarium and enter equatorial mode or azimuthal mode. And azimuthal mode, the stars go in a circle, like they arc around you, and in the equatorial mode, they go beneath your feet. Like it's just kinematics, boys. It turns out.
Yeah, dude. And azimuthal represents your actual observation on the flat Earth viewing a hemisphere, and then the equatorial is just the conversion to the globular celestial sphere. So you can switch back and forth. So you can see that, like, from within it, they look identical, right? Except one of them puts it beneath your feet if you turn it off. I mean,
But yeah, to bring it back to to Von Conspirator's point,
That's the
to,
grace. That's the
to
grace of love. That's the grace. We get to.
Go ahead, Alan.
oh, you're good. I was going to say, to bring it back to Von Conspirator's point, just because they have math and ratios and things to describe things, it doesn't mean anything that they're saying is like necessarily physical or have any physical meaning behind it. In fact, what you'll find as you get further into astronomy and physics, it becomes more and more abstract and not and with no relation to reality at all, and it just becomes the output of computations where the input is what they expect and need for model expectations, and the output miraculously fits what was expected by the model.
Miraculously or validating the suspicion.
Yeah, I mean, how many Feynman diagrams would you like to solve before you can definitively say which path the proton took?
I just like one. I would just like one formula with numbers in it. Yeah, electrostatics for how.
Is it just me, or is his mic bad?
Yeah,
terrible.
Ron, your
Yeah.
mic's a little off.
Yeah,
Not sure.
yeah, it's coming in real grumbly.
Oh, am I sitting too close to it? I've moved away a bit.
No,
Is that better?
no,
real
it's maybe unplug it and plug it back in. It's like one of those issues.
Oh,
oh, that made it way worse.
Yeah.
okay. I've never had the problem before. Right?
No, you were sounding good all day long. It just started.
Classic Twitter, honestly.
So what have you guys been up to? Talking about the foundation of the universe and God and stuff?
Yeah, talking a little time dilation.
That's some people's God.
I know. It seems to be Peter's. Talking about, bombs blowing up on trains and stuff. Yeah, it's been the whole gambit. It's fun stuff.
We've only been going for 9
I'd
hours.
love to respond to.
What's that, Power?
No, I'd love to respond to Vaughn because, like, we went off on a mathematical tangent again, and I appreciate that. Like, there's higher thinkers here, and I think that's wonderful. Like, good luck at breaking the code. Like, but I think for Vaughn, as far as speaking as a Christian, talking about like we need to like the balance of good and evil. I believe that's actually a post fall notion because we weren't built for that. Actually, we were built to walk in the garden, and the Lord breathed into us. So whatever this evolution situation is, we were breathed into with his breath. And then because of the fall, he basically said to the people in heaven, who we don't know what like there's all that too, but like, okay, so it's not fair for them to live forever. We were built to live forever. And so that's why Jesus came back to do that. So it, again, it doesn't matter if it's flat or, I appreciate, like, it's a good angle, but it's like, this is a life source. Like, you step on an ant, that ant was animated by God. You step on it and it's no longer animated. Like, so this is a courtship. Like, God left us with his creation to, like, reach us and come back. So again, I mean, because Vaughn, you said that, and I just wanted to kind of bounce back, and we got off on, like, some good stuff, but I just think it's that simple, and I just wanted to add that because we're Christian, and or I think you are too, and we believe we're all in this, we're all trying to get to the same place, and I just think it's simple because
Well,
God.
don't you think that having a lie so big that it can hide even God itself would be a pretty worthwhile conversation?
But how is God hidden? So you're talking about powers and principalities, and they've lied about everything.
Have you heard of the Geneva Bible?
I read the 1599 Geneva Bible.
Have you read Ephesians 6:12 from that Bible?
I can cite it. I
Why
can
don't
cite
you
it if you want.
do it? Bring it up. Bring it up. I
It
can't,
says,
like,
"For we
I
wrestle
don't
not
memorize.
against flesh and blood, but against principalities and powers, and against the worldly governors, the princes of darkness of this world, against spiritual wickedness, which are in ye high places." All right. The worldly governors was removed from our modern day Bibles. I wonder why, right? It's not just principalities that we're fighting, it's the worldly governors. They have an agenda that they want to hide things from us, because if you knew the truth, right? I mean, people are always talking Epstein Island this, we need the list, right? If you knew what these people were really doing, you wouldn't care about no list, right? They lie about
No,
everything
because it's in
for
the
control.
Old Testament. But everything that they're doing now was done then. That's why God, if you read the Old Testament, and I read the Geneva, I love that you read like, the Geneva Bible is great because of the footnotes. If you speak English, it's great because it's a great translation. And if you go into the footnotes of the translation, it's very rich. And I'm not saying it's the only scripture to read, but it's a good one to compare to others. But so it's like, yes, it's the powers and principalities, and it doesn't even make a difference because that's where we are.
Well,
That's
I disagree with you. I do think it makes a difference, but I appreciate your stance that it doesn't make a difference. I don't want to keep going back and forth that you don't think it makes a difference. Honestly, not
well,
that
because Jesus won, and
Well, again,
we're
again,
his creation,
I
and so
appreciate that. I appreciate that. I mean, you believe in God and you're cool with it, and you don't care about the shape of the earth. It doesn't matter to you all that much, and I think it matters that much to me that I hold space and talk about and stuff. So I mean,
no, but I just want to know why it matters so much to you, and it's genuine. I'm not, like, trying to debunk you because
no,
to me,
it's
I'm
all
We're just
good.
curious. We're just curious, man.
It
We
matters
just want
about
to know
defending.
more. Imagine you found a
Yeah,
great
like
deception, and
defend.
it's like, why did they do this? Why are they hiding it? It's like, why does a detective try and solve a murder? Somebody
Why
has
do
to
they
do it.
lie about every experiment about interferometry since
Defending
the
the word.
1800s?
I mean, like I
Defending
said,
the word of
you
God.
asked what the implications were. I said it's about saving your soul. There's all other little nuances in between there, but that's the ultimate thing. We got a bunch of atheists out there that probably wouldn't be one. Whether it's round or flat, we got atheists out there, and
Yeah, the whole deception pushes everyone towards hedonism, selfish, paganism, nothing, and then you get like evil, and then nothing matters. You get relativity, so you get everything's relative. You get more relativism. You get relativism through philosophy. It leaks into every aspect of human life until nothing matters, and there's no repercussions, there's no punishment. Everyone just does what they do, and then you do as thou wilt, which is the state and creed, and then everyone can just be easily convinced and enslaved by telling them not to trust their senses and to trust authority, and that's how you get to the road.
exactly. What's up, Taylor?
right. So that's overwhelming. I mean, I'm sorry you didn't call on me, and I'm probably going to wrap it up with you. And I didn't mean to irritate you in any way, but
You
basically, you've tried to overwhelm us. And so I guess that's your point. Like, I'm just trying to get to, like, what the point was.
Yeah, the point is that they're like, if you knew the true nature of reality, everybody would believe in God, and they have an atheistic agenda. The Biden administration had a $500,000 grant to promote atheism worldwide, and it's about defending the Word of God. You know, the Word of God says certain things about the nature of the Earth, and then if people say, okay, well, the Earth is actually never going to be moved, it's actually moving through space at however many miles per hour, depending on what you're comparing it to. So yeah, it's moving thousands of miles per hour through space. So how does that equate with the Word of God that says it'll never be moved? So it's many different things, and just hiding creation, stuff like that. And
Well,
to
they
me, the
tell us
Bible, it didn't necessarily remove it of the governing authorities, even though that was there. It does say rulers of this world instead of governing authorities. But yeah, the governing authorities, we bow not against flesh and blood. But these are not flesh and blood. Okay, so this shows that the governing authorities are they're more principalities than just the people that you see.
they tell us we're on
I agree with all of that.
They tell you you're on a spinny space ball, but every observation that you can do proves otherwise. They tell you that you're hurtling through space, thousands of miles an hour, but every observation that science can do to prove that fails. They tell us that we're spinning, right? We're spinning. Yeah, every scientific observation that you can do proves once again that you are not spinning.
That's not true.
Yeah,
As
and that gets
Mike, he's right.
then they get you to go against your senses. Like, sure, it looks like the sun is moving, but actually you're going backwards. Sure, it looks like it feels like you're not moving, but you're actually rocketing through the thing. And then it's a slow like tiptoe to totalitarianism where they can just like, listen, nothing that you know or see or experience is right. You have to come to me and the experts, and we'll let you know what truth is, right? And then of course you're already lost.
Would that be anything like one can only get to the Father through me?
A little bit better, but you still sound like you're underwater.
I don't know what the heck happened to your mic, man. It is coming all ruggy.
Yeah.
Even
All right. So I'm on BlueStacks, and I muted all instances and came back, and you're saying it's bad. I'll drop. I got to go get some stuff done. It's Saturday.
have you try resetting the app and come back in? I don't know why, man, but yeah, it's you're sounding good all day.
Yeah, he was perfect earlier. I don't know who was first. We got Morph HQ, and
I think
Karen.
I think it was Huff, Karen, and Morph.
Morph was before me.
Okay, I was wrong. There you go, Morph.
Yeah, go ahead, Morph, and then I'll put my hand back up. I'm in the middle of something, but I wanted to talk to Power, but I think maybe she didn't leave.
All good, thank you. What up, legends? Yeah, I wanted to say exactly the same thing that Shane was saying. A lot of people say, what does it matter? But it literally detaches you from your natural senses. But that was what Shane already was saying. I mean, you see level and flat, but you're supposed to be told it's curved. You don't feel yourself moving, but supposedly you're faster than the speed of sound. So what does it matter? It detaches you from your natural senses. So what is it doing? It's saying, don't trust your feeling, don't trust your eyes, don't trust your senses, just trust us. So it matters a lot.
As a matter of fact, you're too dumb to know what you're even seeing or experiencing. So let us actually educate you on what it was that you just experienced, right? Like they take it to the next level.
Right.
That's literally how they enslave people.
It's like the infomercials, right? Ask your doctor if you've ever had an allergic reaction to a vaccine. If this drug is good for you, right?
You're far too dumb to know health. Which poison do you want?
Ask a scientist, right? Oh, and then they compartmentalize it, right? Oh, well, I'm not a biologist, but biologists all agree, right? It's like the commercial. 9 out of 10 dentists agree Colgate is right for you, right? It's the same programming.
Okay, but so let me just interject for a minute because Christ told me I could move mountains. He told me I could move a mountain.
Have you ever
with
moved
my
one?
tongue.
Have you ever done it?
And right now, we are 2-year-olds.
Have you ever moved it?
With a loaded gun.
Please stop interrupting.
And so I would say, what's that?
Can you let other people talk? That's not you.
Oh, I'm sorry. It's just it seemed like they were bouncing off what I was saying, and I didn't mean to. I'm sorry. Go ahead.
Well, you're good. It's a little back and forth, but you're right. That's the thing, right? he told you could do all these things, but we don't see any Christian doing them because people don't have a connection with their creator because we're all separated from him. We all are. We believe all of these things that aren't in the Bible. I mean, the Bible literally tells you probably 100 different times that the earth is on foundations, right? Psalms 104 verse 5, I set the earth on its foundation so that it shall not be removed forever. Yet we don't believe it. We don't believe it. God even tells you himself, talking to Job in Job 38 verses 4 and 5. Where were you when I set the earth on its foundations? Tell me if you have understanding, right? So I think God would know if the earth has a foundation or a firmament, right? The ends of the earth, the corners of the earth. I mean, there's tons of verses, but yet pastors will obfuscate it, right? There's one verse, I'm sure everyone heard it. The army was fighting these wicked people, and Joshua says, tell the sun and the moon to stand still so that we can wipe them off the face of the earth. And the sun and the moon stood still. And my pastor, probably a year or two ago, did a whole thing. He spent like 5 minutes trying to explain how this could have happened. Like, because if the moon stopped moving, then the tides would have changed and this and that. And I was like, it's super simple, right? If the earth is flat and the sun and the moon dance around, right? The sun is like a strong man running a race, right? He just said stop, and they just stopped. It's so much simpler, right? Occam's razor. But
And
we don't want
also,
to.
other cultures documented the sun and moon stopping around the world.
Hey, I just wanted to get in a couple words real quick before my connection dies. I was going to say that, I think one of the most important reasons for us to know about the truth about our Earth is that we have abandoned common sense by actually buying all these really crazy, total violations of basic laws of physics. So, if nothing else, I mean, even if we just leave God and religion out of the equation, I think it's important just for our sense of logic and our sense of common sense to just be thriving for us to understand that all these globe theories just do not hold up to actual real physics, the laws of physics in the world. So I think that's a really important reason to know the truth because it brings us back to logic and common sense.
Back to reality. Hope there goes gravity.
They put it right in front of you. You know what I mean? Most people don't even realize that lyric.
Correct. Dude, if you go over lyrics from artists back till from the 30s, they are literally screaming it from the rooftops. Not just one artist, no, like hundreds of them in multiple songs, multiple lyrics, but all we do is nurry along with the melody and don't even listen to the lyrics.
Which
And they've been
songs?
telling us for decades.
Which songs?
Californication. Space may be the final frontier, but
That's
it's
a good
made in a
one.
Hollywood basement.
That's one of my
Exactly. You don't
favorites.
have to go back to the 30s. There's Pink Floyd with their album Dark Side of the Moon. That's what that prism explanation is all about. There are recent even the Beatles, Paul McCartney, all those guys talking about the Fool on the Hill. Just
Talking
check the
about,
lyrics out. They're right
they were
there.
singing about Aleister Crowley too, man. 20 years ago today? I forget how the lyric goes, but yeah, it's crazy.
Oh, lads, I shared with the Jumbotron there a bunch of stuff that I mentioned earlier, the Buddhist flat earth model and all that stuff, and a breakdown of the diagram, etc., with citations and stuff. So if anyone wants to follow that or look more into that, those books are available on the interwebs.
Nice. Walter Bislin, before Walter Bislin was Walter Bislin. And then we got Shane.
Who did it first?
Why is the
Walter
Jumbotron so
Bislin,
broken?
all of Asia, or Shane?
Yeah, what up, dude?
What's up, Piezo?
What up, lads?
I
How's
haven't
your
seen you on
Friday
Twitter
night
in so
going?
long. I had to go check Discord. I'm like, am I in Discord? No, he's on Twitter. No shit.
What's up, boys? Life been busy, you know what I'm saying? But is there any sciencing happening here? Where's the
We're
globs?
trying.
I mean, trying to get S'd up, bro? What's up? What's the latest and greatest in,
We'll
in
do a
science? Because
challenge.
I heard that there's a tale of two triangles that's going around, possibly a third triangle, because Stone made one as well.
Well, I see our boy Indio down there, and I see that this could be an opportunity for us to bring the rest of the flat Earth community on board with celestial theodolite. If you guys are interested.
Oh, dude, using Indio as our representative middleman in
Yep,
between guy because he's such a level-headed, cool dude. I'm on board with that immediately.
Does somebody not like the celestial? I can't even say it.
Well, our boy Amish
Yeah.
has an interpretation of it and some emotional feelings about it, and has been making rounds trying to, I don't want to say poison the well, but effectively poison the well.
Is that Jesse Patholite?
No, it's some of our flat Earth boys, the brethren.
So TLDR, Celtheo is something that caused me to learn about what quote unquote celestial refraction is as opposed to regular old Snell's law refraction and terrestrial refraction. And diving into that, I realized that that they're literally just manually correcting every single observation of stars, somewhat near the horizon in order to force them to match the globe, because they have a prediction for what it's supposed to say or what it's supposed to measure, and zero of them measure it without. Actually, I shouldn't say zero, because technically you could have some place on a curve where that would be true, but they like 90 whatever percent of them don't match, and they have to go in and take the deviation between observation and prediction and say, oh, the amount that we were off by, that's actually being caused by this second type of extra special refraction. I'm like, okay, cool, dope. Can I see the formula for it? I'm sure it's got like temperature and pressure and all that stuff, like all the other formulas for refraction, right? And they're like, actually, we just have a bunch of arbitrary random numbers hard coded into it, and the only angle we plug in is the FE plane trig angle. Yeah, it's pretty bad when you actually realize what they're doing. Legitimately, just forcing all observations to match the globe, quote unquote, by taking every observation and running through a curve fit formula to make it match the curve of the globe, because it doesn't.
So you're saying that the backbone of the globe is empirically derived coefficients to make the angles that correspond to time still make sense when the stars are visible way longer than what the globe predicts, irrespective of refractive conditions. That's just like what it would have to be.
Yes, and in short, you go in, you take your plane trig angle, then you subtract the glob drop over distance, so now it's a glob angle. Then you also add the refraction for temperature and pressure in Earth's atmosphere. You do that, right? So you take your regular straight up trigonometric angle on a plane, subtract the glob drop, subtract or add or whatever the refraction, and you're still way off. And so then you're like, how could we be so far off? This doesn't make any sense. Why? Oh, you know what? There must be an extra set of refraction happening. There's another refraction layered on top of the regular refraction that's also happening simultaneously, but it's not caused by the same source of regular refraction, because otherwise it would appear as regular refraction. So we're just going to have zero actual physical variables in this formula, and we're just going to go outside, and what we're going to do is we're going to take like hundreds of measurements, and we're going to take all those and plot those in Excel, and we're going to produce a curve out of the measurements we actually got, and we're going to compare that curve to the curve of the predictions we have for the glob. And when the curve for the real world measurements doesn't match the curve for the predictions of glob, we're going to create a formula that will correct the first curve and turn it into the second curve. And that formula, we're going to call that celestial refraction. So every time you go outside, whenever you look at a star, you got to first spit it through this formula. That's how you know the glob's real. GG.
Yeah, man, I just put the graph of the data backing up everything you just said in the jumbo, and it shows how the red line is like the refracted the globe prediction, and the yellow line is the unrefracted globe prediction, which is way lower. Refracted puts it way higher, but it's in no case is it anywhere close to the flat Earth prediction, which is right at that baseline within like 50 to 60 meters every time. It's wonderful.
I'm so
Yeah,
glad
and
you made
see,
that chart. That's super cool. And y'all should do a presentation on the celestial refraction.
oh, there's been a lot of them.
I think I did one. Did I? Did I not do one? All right. Yeah.
A
It's in.
dozen?
Yeah, I have several. Every time we do. Yeah, I do
We
it
do one
often,
every
Every
week
Taylor.
or whatever.
I do.
yeah.
Y'all
Piezo
never
just
invite me.
Piezo just did one live. He just
Nobody invites me.
he
I'm like,
just Taylor. He just did it. All the keynotes were there.
Should be noted that this has no correction
you
value and
noted
no
nobody invited
adjustment.
me again.
You're
But you
here,
invited you.
You're here right now.
Taylor. You're here.
I'm like, I'm in a world presentation.
Oh, you know what Taylor said the other day? That she needs custom invitations to everything we do or it doesn't count. So
Oh, by the way, just so you know as well, this this formula for celestial refraction, right? If you do everything I just said, you take the flat angle, subtract glob drop over distance, which is also the same thing as, sky shift over distance. So, chew on that for a minute. But either way, add the drop over distance or sky shift over distance, add refraction of the Earth atmosphere. You're still way off. So then you add in that little, celestial refraction correction. Now, when you
Are you talking
do
about the
that,
C factor?
yeah. Now when you do now when you do that, right?
That's like
There's
a
only
triple entendre, bro. Sorry, go ahead.
yeah, when you do that, when you add in celestial refraction, right? It's not like regular refraction, as I said. It doesn't have any physical variables like temperature or pressure or anything like that. It's only got everything is hard coded. It's just a bunch of like concrete numbers that are constants hard coded in there. There's only one variable. It's an angle, and it's actually the plane trig angle, the flat angle, the flat Earth angle to the mountain. And the thing is, bro, is if you switch that angle, that FE angle, and you use the glob angle instead, keeping all of the things in the formula the same without changing any of the rest of the things I already said, you will not get the correct prediction. You will get it'll be closer than without any correction at all, but it'll still be off. Right? The correction that makes it match, 99% perfectly everything you see in reality is using the plane trigonometric angle. If you use a spherical trig angle, or in other words, a glob angle, it is not as accurate. So that also goes to show you, like, if we're just sitting here on the Earth and I've incorporated all the things I already need to incorporate, right? Why is it that the angle that I add into my celestial refraction, quote unquote, formula that makes the correct prediction is the flat angle? Why would it not be the glob angle? Aren't we supposed to be predicting reality right now? I don't know. Pretty came out during that Prezi back in June when Alan and Mike were talking to Jesse and McToon. I thought it was pretty funny because when Alan dropped that little nugget of truth, there was a hard pause and a little bit of a jaw
well,
drop there for a few seconds. I found
so
it very amusing.
dude, there was massive resistance to that. And actually, now that I'm balls deep in the spreadsheet, I can tell you that they've changed the way that they do everything is different. For instance, they no longer like they have a religious a religious propensity to disagree with starting with the flat Earth angle. So what they do is they do not rise over run. They do rise minus the difference in globe geometric drop. So they do like 360 times the distance divided by 2 pi r converted to degrees. So they're like, and then they subtract it from the height, and then they take the arctan of
Wait,
that.
what
So
distance? What distance?
No, they have a different starting triangle. They don't use the actual height of the peak over the. I
Yeah,
mean,
but the bottom leg of the triangle can't be a straight line on the glob. They'd be
well, yeah,
doing an
no, they
arc.
are. Yeah, well,
So it's a bendy triangle. You can't even. Yeah, okay.
no, they just make a lower triangle as a base to start because they're using a lower angle. So like
So it
instead of
slices
doing
underneath the ground.
yeah, so essentially they're making a refracted triangle, right? they're adjusting to the point that's in refraction, and they make a new height based on that. So they're taking the arctan of that slightly different, slightly smaller triangle as their baseline, and that's what they start to apply corrections to. So they're so resistant to starting with the flat Earth prediction, a basic arctan rise over run, that they do that convoluted mess so they can have this, so they can pretend to have their own starting point. That's for starters, dude. That
Even though that angle is literally just the plane
Yep.
trig straight up angle
Yep.
minus a factor.
Even though it's not about terrestrial refraction at all, and it has no basis in observing stars, which is what we're doing, they insist on applying a terrestrial correction. I think it's like two
arc minutes.
Yeah, 2 arc minutes per kilometer or whatever. No, two arc
No.
seconds. 2 arc seconds per kilometer. It's such a tiny thing per kilometer, and they do a ratio, and they apply that on top of it, even though it's not being observed. So then they take that and they call that the Heffron angle.
Oh, they call it the Heffron angle.
Literally everything that the global spreadsheet
That's what Mike was doing this whole time. You just didn't know it because
and then they go and tell people, "Oh, look at the process." Look, and so like all of the data in the globe sheet ends up different. So they have different predictions. They're no longer doing what is the Heffron method, right? Let's call it the Jesse path of horseshit method, where everything is different.
Okay.
So then so because you said that and we called it out that they were using the flat as the baseline, they did all of this extra work so that technically it's not anymore. Just so everyone's clear.
So we're just gonna pretend we didn't start with a regular distance and a regular height.
Yes,
and we're gonna pretend that we have a triangle.
Do they apply those methods when things are directly overhead? Sorry to interrupt. And how's my mic now?
Much
It does
better.
sound better.
Yeah, perfect.
Are you familiar with the?
Awesome.
Are you familiar with the Dr. Heffron experiment there, Roundhound?
No, not at all. Should I just look it up,
The
or do you want to tell
celestial theodolite.
me? No, not familiar. Should I look it up, or do you want to tell me?
No, it'll take a while to tell you.
All right, I'll look it up. So, Dr. Heffron and celestial theodolite. Got it.
Go back to like June 4th or 5th on Space Audits YouTube, on Alan's YouTube. He's got it. But
What? You're not going to give him
yeah.
the TLDR?
Go to June 5th. Okay.
But Shane, they are basically saying that their triangle's base is curved upwards.
Yeah.
And they can still apply trigonometry to it because yeah, I mean they're still using tangent and arctan.
So they're using a refracted smaller triangle with a curved baseline. Yeah, that's how they get their starting point now. So I was looking at
triangle whose base is not a line is an arc, which means you can't use trig on it because it's not a triangle.
No, I get it. I know. I'm with you.
That is the
Wait,
game.
can y'all translate in like layman's terms why they're not using the Mike Heffron method?
All right, Taylor, check it out. How does one draw a triangle? You need what? What is the most basic parts you need to create a triangle? How many of them?
3.
Okay, so 3 lines that connect at the points. Right. Make a triangle. Okay. Now, if I had 2 straight lines and 1 arc and they connected at the points, would that be a triangle?
No.
Okay. So I couldn't just use sine, cosine, and tangent then on this chevron looking thing. Okay. So if we try to do trig on the Earth and we use a flat baseline, we can make triangles because the baseline is the base and the height is the height, and then we draw a hypotenuse. But if the baseline is curved, we can do a height and we can do a hypotenuse. We can't do a base because the base is actually going to go underneath the ground and slice under it. Are you tracking?
Somewhat. What was that last sentence one more time?
The base on a glob is not a straight line. It's curving everywhere. It's a sphere.
Yeah.
So the
What's
base
the point
of
you're
any
drawing it to
triangle,
then?
the base of any triangle that you draw along that surface is, if it follows the surface, it's not going to be a triangle anymore because the base is no longer a straight line. It's a curve. In order to make it a straight line, you would have to actually dig that straight line underneath the ground so that it drew a truly straight line under the ground, and there's going to be like a hump of earth above it. That would be the only way to actually make a real triangle.
Making a diagram now.
You would have to actually dig that straight line underneath the ground so that it drew a truly straight line under the ground, and there's going to be like a hump of earth above it. That would be the only way to actually make a real triangle in order to be able to use trig. But then if you did that, if that is what you did, then the angles on the ends would not match anymore either, because you couldn't use the angle on, the other end of the base from 90, because that angle part of it would be obstructed by the ground. So it's not really a true whatever angle it says it is. It's not really that angle because it's being cut up by the ground. So you wouldn't be able to use trig if you were doing that. You would have to use spherical trigonometry. They don't do that, right? Like, nobody's using spherical trigonometry in any of this. You just use plain trigonometry showing that you have real triangles, and then they're artificially subtracting, quote unquote, drop over distance and subtracting refraction, still not ending up at the correct answer. And then they just make a mathematical fix for the difference that they still have left to make up, and they call it celestial refraction. Heffron's method just uses plain trig. Their method, which they have named the Heffron method, uses plain trig still, but pretends that they're not using a flat baseline at all.
Yep.
And they just use what the equivalent distances would be for, the plane distance minus, or plane height minus, pretend as if it has no connection to a plane.
Can I ask a question?
Yeah, Jesse told me that he didn't use refraction or anything. He did the same thing as Heffron and got his results. So.
Yeah, that's because Jesse tells bold-faced, aggressive lies
Is
exactly
there
about what he's
a
doing.
one sentence?
Yeah.
Every observation that has a terrestrial and celestial correction. So whatever, and then he calls it like the Heffron method, when his method now is entirely by different multiple steps different than what we're even doing. So
Yeah,
to even say that he's comparing it is disingenuous.
he's been doing that the entire time. He's literally done stuff his own way and then called it the Heffron method for like
Yep.
2 months now.
Yep.
And it's
Aggressively
like,
lying about it, dude. Actually makes me sick.
Yo, Taylor, in
he
the
has like a pathological tendency to lie.
Yeah, but he's doing like supreme damage control, and he's like literally the globe's only hope right now, because everyone, all they do is just go, oh, don't worry about it, Jesse's taking care of it, right? And all Jesse does is lie aggressively, misrepresent. And if you look at his spreadsheet, all of the data is different, right? He's comparing the methods, but his starting point is different, his elevation is different, his angle is different, his flat Earth prediction is different, and his globe Earth prediction is different. So what the fuck is he even comparing? He's done all of those his own way. They are all now enough different that they're not even comparable to the method. So when he comes back and he's like, behold, I've debunked the method by doing something totally different. Like, what? How does that even make how does that make sense? And because nobody
Have y'all tried to put his raw data and do the calculations yourself?
Yeah, well, I just explained
Taylor,
what he's doing that's different, right? He's starting off with a different triangle, right? Which we can definitely replicate. Once you look at it, it's easier. You just start with, like, they call it the delta height, right? So it's not the real height; it's the actual plane trig height minus the geometric Earth curve, which Bennett,
GG Bennett.
yeah, which Heffron calls the drop over distance, which is really just
yeah.
the Earth curve drop, and then so that gets subtracted from flat, and then you add in the Bennett GG.
Wait, hold on,
that's the globe.
Wait, don't forget, this is important. Just to drive the point home, Taylor, Jesse built a simulator where you can see the math being used, and it uses the math we just described 3 times. Flat angle minus drop over distance plus terrestrial refraction plus celestial refraction, or minus, whichever. But that is the formula.
Yeah, I know.
Add up plane trig, drop over distance, terrestrial refraction, celestial refraction. Guess what? That simulator he built using all that correctly will predict the measurements Mike made on his spreadsheet in the real world.
Yeah, I guess I know you explained it 3 times. I guess it just wasn't hitting home because he told me like he didn't use any refraction. So whatever. Okay, thanks.
That's the way that it works. It wouldn't work at all if he didn't incorporate those 2 refraction corrections. And don't get me wrong, I think it's fine to use terrestrial refraction because it only makes a difference of like 2 arc minutes anyway. And obviously it's happening between us and the mountain. Like, that's a fact, right? It's always going on everywhere. But That correction for terrestrial refraction is like 2 arc minutes. Taylor, the correction for celestial refraction is like 13.
It
It's like
depends.
13 arc minutes.
It can be anywhere
It's like
from
15 on average.
six or 7 times bigger than terrestrial refraction.
Yeah, the highest I've seen is 25.
Yeah.
So
the point.
Oh, go ahead, Shane.
The point is that he's the whole thing. He's misrepresenting it because it's so
Ah.
dangerous right now. If you look up, dude, I made a diagram about it, and I put the actual occlusion video behind the thing so we can try to explain it to you. So if you want to look at that, I think it's pretty dope. So you can see the actual star we're talking about being occluded by the actual mountain on the image, and it shows all the math you need to make the prediction. And in no place is there an optic angle to be refracted with terrestrial refraction in the first place, which is why the whole diagram points it out, right? Because if you use a old school camera to make a recording or a telescope and you got a watch, that's all you need. And you make that observation of a time. And then when you compare that flat plane angle to where it actually was, it's within, 1 to 2 arc minutes almost every time. Actually,
Yeah,
every time.
Can I just interrupt? I'm not versed in the subject you're talking on, and I really have to get up and do some stuff. Ken and Brian, thanks very much for having me. Peace out, everyone, and catch you another time.
Later, Round Pound. Catch you on the Fleazy.
Yeah, see you later. Check out that video there, Space Audits.
Yo, sorry, my mic I had the wrong mic inputted. I was trying to contribute. The highest refraction correction I've seen is 25 arc minutes, bro.
Oh yeah,
Yep.
crazy.
That's
Almost happen to
insane.
agree.
That's insane. Think about what that is in real seconds.
In Mount Rosa, the drop over distance correction is 25 arc minutes, and the GG Bennett's 15, as an example.
Yeah, that's like.
But that's correct.
60.
And when he uses this formula, what he matches the stellarium prediction for atmosphere on and off, and then from the observer to the peak. That's what gives you the Earth curvature drop. That's where you got the distance. That's how he knows it's right, and that's how you can confirm whether our globe Earth prediction is accurate, right? Whether it agrees with stellarium's prediction. Because now Jesse has a whole different set of predictions with his extraterrestrial refraction added in that match nowhere. So there's no way for anyone to actually correct or double check or hey, are his predictions right compared to what? He's made up his own completely different thing now. There's no way to double check them now. When we were doing the Heffron method, the predictions were checkable in stellarium. Well, like I said, with atmosphere on and off, you could tell whether you were on the right track. If your spreadsheet didn't match the stellarium globe prediction, you would say you were doing something wrong. So now he's saying, well, we're strawmanning the globe by matching the globe tool, but he's not doing his own crazy random thing with nowhere to double check anything. So crazy.
The problem that I was going to say in conclusion is Taylor and other people in this chat that are listening, most of you that are good faith people, you probably give too much credence and good faith benefit of the doubt to people like Jesse. See, it's like
Jesse's a lying asshole, man.
You come in and are a part of a community where you're known for, on the years scale, and then a topic comes up and you consistently lie about whatever topic is at hand for like multiple months and are caught in chat contradicting yourself and also making false claims about other people's work, and you're exposed and known by everyone familiar and versed with the topic of what's happening that you're lying and doing this. You develop this reputation and everybody knows, and no one wants to deal with you because that's how you are. But then what he does is he lurks for people who don't know him and don't know his reputation or know anything about him, and he plays this persona of this like super innocent kind Christian guy who just wants to know the truth, and that's all. And no one wants to engage with me. It must be because I can prove them all wrong and they don't want to hear the truth. Oh, poor me. And that's how he tries to get people. You just have to accept some people just exhibit snake behavior, and that's the way the world is, and then move on and not pay any more attention to them. Just period, just drop it and be done. Like, you just have to do that with some people. He's one of those persons.
Well, irrespective of any of that, check this out. A big aspect of this argument, right, is the occlusion timings and this refraction argument that well after the star is physically below it, it's being lifted up, 20 arc minutes, 15 arc minutes, 13 arc minutes, etc., right? So when Jesse used his simulator to find a spot where the angular expected globe drop was the same as the celestial refraction amount, he used the occlusion timing, or I'm sorry, he used the emergence timing based on the true position of the star, which is part of our method. That is what we do, but that goes against the apparent position that the globularist must always take. So he actually validated our methodology that the occlusions are physical, and the angle that they're visible or invisible, depending on if it's emerging or occluding, depends on that physical angle to the mountain. So that it completely undermines all the explanations where where like it just takes refraction off the table, like just altogether, and then they're left with the raw, right, which is too low. They predict different timings, and they're just not there. So the methodology is valid, and the globe can only exist as a ratio of when ideal conditions are met, where they're like, if you're at sea level, there's going to be enough celestial refraction correction to apply, and that's where they took their measurements. And also, fellow Aether cosmology or cosmologist Goose took a measurement at sea level, like 5 meters above sea level as well, and the celestial refraction correction is very close to the angular drop as well, and it quote unquote matches the globe in that regard, but only as a function of that exact ratio. Literally anywhere else that isn't that, it doesn't work. Like if the earth were a globe, you could go anywhere and get glob timings, because the mountain's physical elevations would be physically lower relative to you, but they're not.
Isn't that magical that like in that simulator you've got like the geometric flat prediction, the geometric glob prediction, and you're like, oh, we can make it match the geometric glob prediction. It's like, but is that line, the two lines are matching? It's like, is that line really the geometric glob prediction? Like the one line is, but the other line's not. The other line has celestial refraction built into it.
Yeah, I loved it when you said, "What is line 15?"
Yeah, but
Yeah,
again,
and
since then they changed the
no,
whole process in that super convoluted way I described.
no, yeah. So to be fair, they did change it, but also in reality, like when you're cell naving, you're plugging in just a raw angle. That's they call it a tangent on a sphere, et cetera, et cetera. But it's just the raw angle, and that formula correctly interprets it to put it where it needs to be. So even though they've done this method where they can derive it in a way that is not even like geometrically viable, it's not. It doesn't matter. You could, like, in reality, if you're going to do it,
Yeah.
you just use the raw angle.
I
You're
put
set.
Jesse's picture. I depicted his whole observation. I did a thing, and I put that in the jumbo too. It says his actual observation in the background with the actual angles. And when you do the trig at the end, guess what? The reflected triangle still fails, meaning the flat Earth prediction for the actual elevation of the peak during the occultation coincides precisely with flat Earth trig elevation and not his, because you have to take a tangent of a lower angle if you're the globe, no matter what, to confirm that elevation, because it's refracted, because it's lower, because it has to be, right? Because it's different. So you're always getting a lower or a wrong actual elevation. And in his example, that Blinn Mountain is 650 meters. Flat Earth puts it at 644 meters at the time of occultation, and Globe Earth puts it at 561 meters. So he's still 90 meters off in his own example. Anyway.
Yeah, the aspect of it is super important. The backwards deriving the elevation of the thing that did the occluding based off of the occlusion angle and the distance. Like that's the only analysis that matters, right? Like the whole J value thing, none of that, that's all supplementary. We can
I think Mike
completely
did that.
disregard that.
Yeah. Because no, Mike did this. The only data he graphed was the elevation, the predicted elevation, and it took me a while before I figured out where that came from. And once you do this observation, you construct a completely separate triangle. You keep the same distance, and you just take the tangent times the distance and the angle, because now you have the actual correct angle. and the globe uses a different angle than the flat Earth angle, right? So, and even in his example, you get a height that, you know, where the mountain must have been at the time of occlusion, and the globe is always wrong because they have to use a refracted height, and that's retarded because, you know, as you said, refracted can't occlude. Well, once it's behind the mountain, you're not seeing it anymore. So refraction doesn't really have anything to do with it. Crazy.
What's up, Karen?
Yeah, all I wanted to say is because I see that the flat earthers are getting bigger. Now they're creating, the Jesuit Freemasons are creating another, including with the flat Earth plateau. They're creating with the vortex, but they're using the North Pole as they're creating with the black sun below the plateau, and with the vortex going around, it's making it look like a globe. They're deceiving again. They're deceiving everyone.
Classic Jezzies.
Yeah.
I forget. I can't find it right now, Alan. I'll find it if you want. But we were discussing that line 15 one night, and Jesse came at me and said that I didn't know what I was talking about. That you had already admitted that you thought line 15 was something that it was not, and you knew it was, you were wrong about it. So, being said, I don't trust him. I would like to hear what you have to say about that comment.
Yeah, he literally acknowledged it and then changed it as Shane just walked us through it. That's exactly why it's different, because of that exact comment. So for him to go around and say that to you is preposterous. That's why I
Yeah,
don't want to communicate with him
That's
anymore. Like
that's why we say lying Jesse with the disgust in our voices that you hear.
well, see, I said that he changed it because I remember the very next day talking about that, and I think Mordwan was coming at me with at first, and then Jesse chimed in. And he had said that day, "Well, I changed it." And I said, "I don't care what you've
I mean,
changed."
we have a copy
I
of the
remember
original.
that.
We have a
I
copy
remember
of the
that.
original version with the angle in it. So
Right. So that's what I told him. I said, I'm talking about what you presented." But then it's like within the last week, he came at me and said, "Oh, you don't know what you're talking about. Alan admitted he thought it was something that it wasn't."
So he's going around lying about that now.
Oh, he's
And
going around
everything.
lying about a lot of stuff, but I just wanted to clear that
So
one
he's
little thing
when
up.
I confronted him about that, he probably was lying about Dr. Heffron agreeing with him. Seriously, dude.
I've never heard that happen, to be honest.
That argument, Ken, that when you had that discussion and you said I don't care about that, you kind of like waffled right over it, but I caught it. And I later on in that conversation brought that up to him. And then that went on for like another few days. And he's like, well, Dr. Heffron said it checks out.
No.
Dead
Yeah,
serious, bro.
there's no end to the amount of lies he will tell. And he's got, there are people that are just solely taking his word for it, because I
A
have
lot of
Glovers
people.
that come at me
Everybody,
and
actually.
they'll say, "Oh, Jesse's already debunked all of that. Uh, so we don't even need to go into it because we know that whole thing's debunked."
Yep, that's exactly the strategy, right? Just throws a bunch of horse shit at the wall. I just tagged you in a post, Ken. I posted it on you. It's a screenshot of Jesse's spreadsheet that I have with a bunch of helper columns so I can distinguish the bullshit that he's doing. So you can take a look at it and notice that it's all different than the actual spreadsheet. All different data, all different predictions, all different elevations. It's just a screenshot, but it's quite apparent. This is his most recent fake simulation, fake spreadsheet, whatever you want to call it.
I can't believe all these globies can't understand that he's lying about this. I mean, seriously, that one where you caught him on that line 15, he kept on saying, "Well, I can get." Dr. Heffron explained the premise of this thing like 47 times to him in one debate. It was ridiculous.
They don't want to get it is the issue, man. Like they're involved in this conversation for completely different reasons.
Yeah.
I feel like there's some of that on both sides, you know. Some people are in on it for completely different things, you know.
I believe that too.
Yeah, I do respect what y'all do in Ether Cause, especially when y'all do the paper readings and everything like that. Like, I think that's really important. So I appreciate y'all.
I
We
appreciate it all.
appreciate you, Sheepdog, putting everyone in headlocks and other jujitsu moves that I don't know the name of. Some sort of arm bar or leg lock.
Sure, man. I guess you can appreciate that. It's fun.
He said jujitsu is the only time he gets to hug another man.
It's man cuddling, dude. That's what it's called. It's called man cuddling.
It's like, get on top of me and see if you can pin me, bro. It's not gay. No.
Totally not
It's
gay.
just a friendly exchange of bruises.
I saw a video the other day. It was like, hey, you want to roll? And he's like, oh, you want to be dominated by another man? And spent like the entire match on top of him.
Yeah, you showed that gay guy, dude.
Oh my. Jiu-jitsu.
I like the definition of jujitsu that said that jujitsu is the art of folding clothes with someone in them.
I've seen that.
Yeah, I think I've seen that too.
But no, I appreciate the conversation. I mean, like, it is important to have the basic conversation, right? Like, of understanding what we're seeing in reality. But then, like, you got to go with what the science is saying and you got to have that conversation. And I think y'all do a really good job of dissecting that because, let's face it, it's not easy for everybody to read a science paper. Y'all break it down for simpler terms for us to understand. So, thank you.
Shout
And
out to you guys.
luckily, a lot of what they've done is just use, specific definitions for things. So once you know the definitions, it's a lot easier. So that helps a lot. So like, don't be super
Proper
intimidated,
terms.
lads.
Yeah.
Yeah, I hear function 6 is or F6 is a good. Is it F6 or F12?
Well, dude, it's all meant to be
9/11.
discouraging, right? It's meant to be intimidating. You're meant to be like, I'm too dumb to figure it out, right? Just take relativity, right? They're like, oh, I'm too dumb to get it, but other smarter people definitely know that light speed is constant and everything revolves around that, and muons are real and time dilates. I get it. Like, I don't have to know. I believe it, right? And they do that with a lot of things. So
Nuance. I said neurons. What a dick.
I don't know enough about it, but I know that you're wrong.
Dude, I remember when
Classic
FTFE said
quote.
those words. Dude, when FTFE said those words the first time,
Yeah, exactly. I mean, yeah, that was the shout out. But I mean, they all do it. It's not just FTFE. It's everyone. It's all of them. I take that back. All of the anti-FEers, there might be some actual physicists out there that understand it, but it seems like even like Peter and Franco don't understand what relativity actually says.
But that's by design, right? That's because they make it convoluted and they take out things and then call it other things, and they pretend that things are particles and waves, but secretly use only wave mechanics and wave equations to describe the motion, and then tell you that when you're not looking at it, it's actually a little BB shooting around made of, like, so the whole premise is made to be convoluted so that you just either turn off your brain, disengage, or you throw up your hands and you go, I'll just ask the experts, and they're like, oh, hand rubs vigorously, right? Like, we have just the experts to tell you what we want you to know or whatever.
Dude,
and we ran into that today.
I watched this guy do an equation on this, talking about the Lorentz transformation, and he didn't use one number other than like squaring some letters. I'm like, that's what the fuck, dude? Talking about gamma. It's ridiculous.
If you guys want to see a good Lorentz transformation video, if you go to bitshoot.com or .net, whatever it is, and search Man of Stone, his he has a video on it. It's hilarious. He shows you like how much the Lorentz contraction factors are. Guys, it's not even a real thing.
Of
Well
course, it's
said,
not a real
Alan.
thing.
That video is called A Couple Thoughts About Einstein. I couldn't recommend it more strongly. And if you want a little palate cleanser right after that, go see the video that is also on that list called Light Propagation, and rock it out a little bit, shake it loose.
Talk about light propagation.
Oh my god, you're so much worse than Stone.
Said you can bang at a lot of nerve. No curvation, straight or curve.
I will say this:
Yeah.
it is frustrating when they say something that I don't know anything about, and I'll admit it. Oh, so you don't know? And it's like, bro, like, if I don't know, I'm sure if you gave me like a week or a month in my spare time to look into it, I could probably find problems in that too. And
That's
then
what
you'd
we
be
do.
pissed off.
That's what we do. That's what we
It's
do. Out of
exactly
spite.
what we did.
Yeah,
Yeah,
that's
out
how
of
it
spite.
started.
They're like, "Oh, you don't know?
Oh yeah.
Like, give me a week. I'll know everything about it.
Like,
and
I
more
may not
and
know it
more."
now, but fucking wait.
Dude, I'm over here trying to learn relativity.
Dude, we all did. We had to learn. As soon as I saw Witsit wield it in a debate, I was like, okay, we all gotta fucking learn about this shit. And then I met Alan, who was like 4-hour presentations deep into it. So I fucking learned. I learned, bro. I watched that first pres like 4 times at 4 different servers. Yeah, you had to at least absorb relativity through osmosis by then, dude. I could have given it myself.
And hey, by the way, sorry to rope y'all into that calculus thing. Some guy who's apparently works with satellites says that he'll pay for your calculus exam and give you $1,000 if you can pass the calculus exam. He wants the results shipped to him.
I know I took Calc 1, 2, and 3 and a bunch of upper level math, but I couldn't tell you a single thing that I learned in those classes because I never used it for anything related to work.
Exactly. It is so
It's been
rare
over
that you can
15
use
years.
calculus in an applied
No
situation.
idea, dude. I couldn't even tell you what I did on one piece of homework at this point.
Can you guys hear me?
Yes, I bet you guys at
Yeah.
least did an integral or something, right?
Mic check.
Yeah, man.
Didn't do anything, man. It's like, come on, man.
I
Flat earthers don't want to do any
I
math.
can hear you, Stone.
Okay, thanks.
yeah, I hear you too, Stone.
You're just a little quiet.
Can you not hear me?
Your microphone does come in low, Stone.
No,
That's
everyone's
weird.
solid.
Okay.
I can hear
How's
everyone.
it now?
It's just
Is that any
just
better?
naturally it comes in low for me.
No, you're good, Stone.
Huh.
You sound fine.
Yeah, Shane, you're good too. Both of you are a little quiet, but we hear you.
Okay. Well, I'm gonna reconnect then. I'm gonna unplug fucking
No,
everything and
No, you're fine,
Yeah,
man.
it's
Good.
No, what's
You're
wrong?
good
No,
still.
I'm
Stone,
gonna
you're
do
good.
this. I think I'm
okay.
good.
One
All right,
person
we'll
can
go.
hear him just a little bit less than everybody else. And he wants to disconnect everything.
You
Fuck
know,
it.
I'm
You
an
can't.
audio
You
guy.
can't.
That's just
You
the way
can't
it
fix
is,
it.
man.
You can't fix it though. It's not
You
you.
can't get there from here.
The issue is on the
Come here,
other.
Stone. I'll give you a hug. Come here. I'll give you a hug.
I'm good. I'm good. Gotta wait for that.
Dude.
We love you, Stone, but you are a little soft spoken sometimes.
Oh yeah, I have to be. No,
Well,
that's on
no.
purpose.
Let me give you a
'cause-
jujitsu hug.
What happens
Because
to you
over
happens to
my
me.
left shoulder is my sleeping wife on the couch, so I gotta generally be a little low key when I deliver
There
at
you
night.
go. There you go. Now
But
you're fine.
Microsoft jacks your control volume like me, and it lowers it conspicuously while you're talking, especially on Twitter.
Oh, totally.
That happens
I'm
to both of
wrestling.
us.
Like while I'm talking to you right now, I've actually got my mouse click on,
I know.
and I'm dragging the volume slider back to its position over and over and over several times per sentence, just to beat the arm wrestling fucking deal against Elon here. It's ridiculous, and there's no way to change it.
What was
Windows
that?
10, for fuck's sake. There's no way to stop this thing from controlling my mic slider. Can't fucking do it.
I
in the Windows
downloaded a
environment.
program called Static Mic Volume, and it resets it every like 4 seconds or so.
Yeah,
That's how I solved it.
Is that a freeware?
Oh yeah.
Static mic volume?
Yep.
Fucking A. Thanks for the tip. I'll be getting that presently. Holy shit.
Set it to like sub 1 second, because sometimes Shane.
No,
It's like
then it gives you like this robot sound, and you happen to speak while it's adjusting. Yeah, that happened to me too.
I just heard it adjust. Oh, that's what that is, dude. That's so gross. Get a new window.
No, I'm not going to do what Stone's doing, which is the only other way, and hold your finger over it to fight it constantly. So there's a slight robot for everything.
Is it time to become a Linux lad?
I don't know. I was gonna say, I don't know about you guys, but I bet Alan and I don't have that problem on Linux.
Oh!
Wow. Linux 1, Windows 763 or whatever.
But you're just gonna live with that? It's so sad.
It's a very inconvenient truth. Okay.
Hey, y'all want to hear a pin drop? What's Linux? Told you.
Never met her.
First of all, guys, it's Linux. You know why it's Linux? Because of the guy who created it. His first name is Linus.
No, it's GNU/Linux.
It's GNU, yes. Jump in your GNU and I'll take you down the river. Yeah, for sure. No, it's Linus Torvalds was the guy who created Linux. It's not Linux, it's Linux because of Linus who created it.
Yeah, so you'll never convince me of that. Like, I know that that's the guy's name, but it's always going to be Linux no matter what.
I'm going to choose to not believe that and keep going on with my other belief.
I like my reality better.
I'm comfortable with my
You can't take this from me.
At this point.
Nope.
Like a Glober. I'm really comfortable in my current state paradigm. I'm not looking for truth at this time.
All time is globe time?
Well, see, in relativity, both your reference frames are correct, so you both are right.
Ooh, touche. I see the young master has learned the relativistic ways.
I'm learning, man. I'm learning. This stuff is stupid, by the way.
All right, everyone repeat after me. Reciprocal transformations.
Reciprocal transformation.
Reciprocal transformations.
That's it.
You guys thought there was a creed prepared.
I keep butting in. Can you hear me?
Can hear you.
Yes.
Yeah, loud and clear.
Oh, sorry. Yeah, I was just going to say, going along with what Sheepdog said, is that, I think the main function, especially at Aether Cause, is for us to just basically point out all the holes in the globe theory. This is what Aether Cause does best, is just basically show how there's no logic in so many of the theories.
It is our favorite thing to do.
Yeah, like you have to.
Oh, we lost her.
That was quick.
Yeah, she just dropped right out of there.
She did just say that she can't listen on the spaces and that it doesn't work with her iPad. And then 10 minutes later, she was in here talking to us. So.
Yeah, and I was just going to say that, you have to basically make so many laws of physics to keep the globe theory propped up.
Man, you got to come up with imagination.
You just got to surrender all your authority and thinking to other people who are smarter than you, who understand it. Super easy to do.
And learn what gamma is.
Gamma's a very.
I do appreciate people like Dr. Heffron and Dr. Bennett who look at you guys and you're like, yeah, you're right. No, good job.
Oh, dude,
good
Bennett's
job
looking into Cell Theo now, by the way.
I was hoping that would happen
without
any of us.
Same. I've just been waiting.
I might have slyly suggested it to Dr. Mike to do it, and he agreed a little bit, but I didn't know how successful that would be. So that's awesome. I hope
is Dr. Mike a full-on flat earther now?
Yeah, he convinced the hell out of himself. We never even asked him if he was a Glober before he was already on board with it. We were talking about the Aether for like 6 weeks, then he was like, "Guys, here's this thing. I'm a flat earther now." We were like, "Oh shit, no way."
He sent me he gave me the null hypothesis thing. Like he was like when he came on to do a Prezi, that was a follow-up to his Aether Prez, and he was like, you guys should use this line of argumentation because it's much more effective. And then like a little bit later he sent me an email. He was like, "Yo, do you think this is like, what do you think of this?" And like I was like, "What the rough, dude?" So I showed it to Piezo, and I've never seen Piezo react so ecstatically. He was just like, "Oh my gosh, oh my goodness, no, oh," So the implications were, just obvious right away. It was it was going to be crazy. So yeah, yeah. Then he was like, yeah, like after the third measurement, he was like, "It's not a globe. It can't. It literally can't be."
Did you? Did I hear you say you presented this to Dr. Bennett?
He's looking
No.
he's looking into it, and so he just now asked me for the null hypothesis PDF. So like like the little prezi that we go over regarding like the null hypothesis and stuff and the angles of and whatnot of Pike's Peak. So he's got all the necessary information now to like understand it.
Dude, did you ever catch him like peeking at one of the prezis at the last 12 presentations? Because I don't think I ever have. Has he ever been to one?
I mean, he watches probably watches them on YouTube.
Good call.
But yeah, I do remember him talking about how much stuff he watches on YouTube.
Yeah,
because he would talk about stuff, and he said, "Yeah, I watched that one," and so I kind of caught that he does watch y'all's stuff on YouTube.
And you can put it on 2x speed.
Dude,
Yeah,
2x speed is best, dude.
Yeah, definitely.
Dude, I like live in 2x.
I remember when Dr. Heffron came on, dude. He was like, "Oh, I guess now I'm a flat earther now." And I remember thinking, "Oh, we forgot to even like try to convince you. We all forgot to drop the ball. Like no one even asked me a question. We didn't pressure him at all. It's like we were thinking about maybe getting around to it, and he was like, "Boom, I'm a flat earther. Oh, and here's how I convinced myself with this brand new method." And we were like, "Double dope. Oh, no way." Which immediately I was like, "Dude, how bad do we feel? We've been doing this for how long? We haven't created a new method of anything. We haven't come with the proofs like this. We haven't come up with anything of our own proof or whatever. He did it in like a week. His first week at the job, he's passing out
Dude. First time just slam dunked it right out of the gate, dude. and then when the angles become ambiguous when things are real close to the horizon and far away, he was like, "Oh, you know what we can actually do is backwards derive the distance too off of the occlusion angle and see what we get." And every time, what is it, Shane? It's closer to the Earth not being, what shape was it? Is it a tangerine, ellipsoid, a geoid?
A tangent plane.
Yeah.
Definitely a plane, dude. It's crazy. Every time you do that, the height is always much closer to flat Earth. It's so funny.
Well, it's a globe. The Earth is a globe, but remember, it's locally flat everywhere. That is the only reason your flat Earth predictions work, is because the globe is locally flat everywhere.
You're just
at
like
the
a flat
same,
plane. Yeah.
yeah, at the same time, yeah.
I remember the other thing he said was that his work with the refraction formula when he went in to read the paper on how they published it, and he saw how the globe proximity, like everything of the globe was built in, hard coded into it. And he was like, "Well, that's no good. How am I ever going to have a mutually exclusive experiment or observation with this shit?" So he thought of a way to remove it, right? Which I think was the best part. Once you force him to predict with refraction, it no longer becomes an unfalsifiable post-diction, which is how they're using it currently to negate every observation terrestrially, even lasers. They even say battle of the beams refracted, right? It's been this unfalsifiable band-aid of the globe ever since. And he's like, "Oh, you know what? The realization is the globe exists in refraction corrections and model corrections across flat plane," and he pretty much proved it. So that's why he's one of us now.
Dude, I was like, that's we've been arguing that forever. He realized it immediately.
Immediately.
And he was
like not 1 week.
Dude, my favorite part of all this, right, was this was all inspired by Taylor's interactions trying with people trying to use a terrestrial theodolite to prove curvature.
Yep. And he was like, "Oh, you know what you should do? Use their own tools against them. We'll grab what they love, the theodolite. We'll turn it against them by using it only to account for an occlusion time and not give a fuck about an angle. And then we'll use plane trick to derive a time based on when we have the star occluded. Boom. Done.
Sorry, Sheepdog. I just want to say one thing real quick, and then I have to leave because this doesn't work. My phone doesn't work for this space thing. Anyways, I was just going to say that, this is why we see that in this whole scientific world, especially astrophysics and the world of NASA, all these jobs are like super, super, super compartmentalized. And this is the reason, is that the left hand should never know what the right hand is doing. And that's why even people who actually are relatively intelligent get caught up in this lie and they buy all this globe theory because their knowledge, their education, and then their professions are so goddamn compartmentalized that they have no idea that all these other innumerable laws of physics have to be broken in order for them to keep working on the theories that they're given to work on, which is mostly math, which has nothing to do with, almost nothing to do with physics. And this is the reason the lie keeps standing. And someone like Mike Heffron, who's really smart, was a glober all the way into his 60s,
Right. Wow. Yeah.
Well, and that's the thing is that all these globies are like, stop using globe mass, stop using globe this, get up your own methods, get them their own methods, and they're like, no, we don't like
that. Yeah, we're gonna do how
They're like,
what can we
don't
do
don't
to dismiss
externally
this?
don't externally test our system. Only reference it internally, where it's always going to be consistent.
Yeah, that's really what it was, huh?
That's the crux of the argument. Whenever someone says you're moving the observer to where he isn't, that they're saying don't externally test my model. Just test it internally, where it's always going to be consistent.
Yep.
Because their whole model is based off of moving to a fictitious observer for time comparisons to get their angles to match to be equivalent to time. So they're like the backbone of the globe is literally moving observers to where they aren't, moving stars to where they aren't. So if you go to test that externally, oh look, you realize that the celestial sphere that they're using is just the old classic hemisphere that you see with a fundamental plane that goes on until you can't see anymore.
Yep. Stars are co-planar with the Earth, dude. That's the indirect inference at the end you can make with the conclusion.
What's up, Sheep?
Yeah, Shane, Alan, Stone, that's here, but Piezo2, and anybody else that wants to dive into this. Have y'all ever heard of my hypothesis on like why things disappear bottom up? I mean, you can talk about like angular resolution and things like that, but like me, it's not really my hypothesis. I kind of like saw Rob Skiba do it, and it made sense. Where he used the Fresnel lens or Fresnel lens for those that want to be a little asshole about it.
Okay, can you link me
To
that video? Somebody was
yeah,
talking about that the other day. I need to see it. Thank you, sir.
yeah, I sure will. I'll put it in the jumbo here in just a second. But anyway, so the Fresnel lens creates a point of refraction, and then it shows as he's pulling this drawing of a sun away, it not only shows it not reducing in angular size, but as it gets far enough away, it disappears bottom up. And that would make perfect sense for things that get really, really far away. And then there's it looks like it's being cut off, but the thing behind the horizon looks bigger than the thing in front of the horizon. And I'm like, okay, is there some kind of lensing magnification going on? And so I don't know, like I'm sure you guys might know a little bit about this, and I would love to work with y'all on it, but if y'all take command of it and take off with it, by all means do, dude. Like I would love for it to be possible explanation for why things disappear bottom up. I mean, the sun's in a different medium. That would clearly explain why things disappear bottom up. I mean, we don't know if it's a physical sun or not, but you know what I'm saying, right?
Bottom up is easy, dude. It's a facet of observer height. You could replicate it in a hallway if you put the observer like in the camera directly in the middle, and you do the same approach, you can see the top and the bottom, the angles will compress equally and they will disappear at the same rate. If you move the camera closer to the ceiling than the floor, the inverse will happen, right? Which is proof positive it's an effect of optics. If you move it to the top, then the top angles will compress more radically, and then you'll see the top down compression, which would be the actual reverse of bottom up obstruction on a flat plane. So then you can do it on a really tall building, like a 54 skyscraper. If you approach it from like 10 feet up and you look up, the top of the building, the highest floors will become obscured first. Those angles will subtend unequally. They will definitely compress higher. So the top floors will disappear first, which again would be the inverse of bottom up obstruction. So then you go back to compare that to like boats disappearing bottom up. The observer is almost on the earth at about 6 foot observer height. You're much closer to the bottom limit than you are the top, which would be the upper limits of the skybox. So of course those angles compress unequally. The bottom disappears faster than the top.
Well, and I understand that, but like there's compression going on and things like that. But for things not losing angular size, like I think refraction or a lensing effect would be a good explanation. Refraction seems to cause a magnifying effect once it goes through the medium and changes direction. I don't know if you've ever noticed that before.
Well,
I put it up top
I think
for y'all to see,
I think an
and then I sent
aspect
it to you in DM.
I think an aspect of what you're trying to like rectify is you like the physicality of the sun, and that's not what we see. Like, it's apparent for everybody. Like otherwise you wouldn't have individual sun rays and individual moon rays and all in corpuscular and anti-corpuscular rays that are individual to the observer as well. So like I don't like
Well, I'm not
the stuff in the sky is like unique to us. So like I don't think like there's a
right.
need. There's not a need to like even give a physical explanation to it, because like I don't think I haven't seen the
I'm not
Fresnel video, but I don't think it's gonna.
I'm not claiming a physical location in the sky. What I'm saying is like, we know that light bends to the more dense medium, right? Well, when you have a temperature inversion, it could be on the same horizontal plane where you're looking out from your eyes to the object. And as the sun moves across your field of view, it gets lower due to perspective in your field of view. So it's going to look horizontal to you in that perspective, and because of that, it's going to be the light path that's going on. Maybe it's crossing through a warm air pocket, which there's dynamics are happening all the time. So it wouldn't be impossible for a warm air pocket somewhere off in the distance to occur, creating a less dense medium. And then everything above it would be more dense because of the temperature inversion. And by doing that, you're going to create an upward deflection instead of what the Globers like to claim is a downward deflection, which is like nobody has ever demonstrated ever. But with Rob Skiba's video, he kind of demonstrates it with the Fresnel lens. You're like, oh, can you do it without a Fresnel lens? I'm like, what do you think is happening off in the distance? The Atmos, the air is having a temperature inversion. It's creating the lensing effect. There might be some turbulent airflow going on in there that's creating a different medium of the air that it's in. I'm playing with it, and I'm still trying to figure it out as far as like getting the whole thing together to be more succinct. But like I said, I'll talk to you guys more about it. I'll come over to Ether College one of these nights and do an after party talk with y'all and see what people come up with. Did I kill the room?
I don't know. I like my bottom up thing. I think that's a really good
I
explanation
like
for
it too
how
because
optically happens.
it's true. It's true. And
You're
then
I'm pretty sure
explaining two different things though. Like
right.
One is apparent object, like the objects in the sky are unique to us. The other is trying to explain why they don't change size with using a physical mechanism where it's not necessary.
Well, have you ever seen a sunset from a plane?
No.
I don't think so.
Yeah, very different. It doesn't disappear bottom up, fades right out, and it looks like the angular size change is there too. So then the argument can be made when you're so far below the actual height of that thing, when your eye is height, when the observer is so much lower, than the actual physical thing. Even if it is physical, you won't see a change in angular resolution. You won't see it decrease in size, and you will apparently watch it set into the horizon if you're on the Earth. But if you're up above, it just fades out like a lot like David Weiss's videos, dude. But it happens all the time. There's one on the plane here. Actually, I have a video that shows a perspective difference when you're in a plane versus on the ground with the sun. I thought it was really cool. I'll put it up there.
Did you say you're gonna post a video?
Yep.
Sheep.
No, I think that was Shane.
I thought Sheepdog said he had Rob Skiba video to post.
I put it up at the top. It's pictures, but there's a link to the YouTube video.
Boo. People don't leave this platform, dude. When they click on links, they're like, "Oh, it's not playing," and then just click out of it immediately.
So many people are like that. They'll
Yeah,
be
just so
like,
you're
"Oh, it's
clear.
on YouTube. Never mind."
Oh, I have to open up another tab or a window. Like, no, I'm not doing that.
But no, like, so the guy
Oh
was
yeah.
talking about refraction and how you could see Chicago skyline. And he goes, so if you turn on refraction, then you can't, then it looks like the globe. But when you turn off refraction, then you can see all the way across. And Rob just like, you see his eyes that get big, like, bro, you just made the answer for flat Earth.
Yeah, this is also the
Nice.
favorite video too. It looks like.
Now he has a longer video that's like 12 or something minutes long. I don't think I've ever even seen it. I thought this video was just more than enough. It doesn't take more than 4 minutes to explain it. But
That
a
would
lot
be
of
hard
people
to
love to talk
quantify.
about the Rob Skiba video where he gets in a boat and he never loses view of, like, you would think at some point there would be a glitch, right? Where the refraction would go away or something like that. And he never loses view of Chicago. So, I mean,
Yeah, that's really nice. I
I
also like
vaguely remember
his
seeing that
Fresnel
one.
lens one. Yeah, that was his big quote come to FE moment was when he and Hammer went across the lake. Because before then he was just like, yeah, I hear what you're saying, yeah, like I hear that this is what the Bible says, but this is what I see or this is what I understand. And yeah, I was just like, well, I said what I said. Now are you gonna believe me or not?
I'll be
So
back
that
in
was
a
the
minute.
test. So that was the test that he came up with just like we'll go across the lake, and if it's a mirage, like they say it is, then it'll disappear. If not, and we're actually seeing what it is, then guess what? That's what it is. And it never disappeared, so they were actually seeing the cityscape.
Therefore, the Earth's a globe.
Dude, what about coffee?
Precisely.
Well,
Gravity.
that timing is a globe timing because I'm a globe lad. So all timing is globe timing, dude.
Dude, that poor soul.
Was that Coffee that said that?
It was so
Yeah.
bad, dude. And then someone directed it directly at Dr. Mike. Like we were ripping on him, and they were like, "No, let's ask Dr. Mike directly." He lasted about a quarter second before he was like, "You fucking retard." I felt so bad for him, dude. We've never seen him get angry. He was just like, "Oh, you're a retard. Okay, I'm just gonna talk to you immediately. I've never seen him act like that. It was pretty funny.
Dr. Heffron called him a retard?
No, but his demeanor immediately, it went from like respectful old guy to this guy's a fucking retard, like very quickly and obviously. It was very funny. You should go watch it.
Well, I was kind of listening in and out.
Because he immediately was like, "Oh, you have no idea what you're talking about, sir." Like that was like his polite, "You're a fucking retard" opener.
Yeah, I was gonna say, man, I was like, man, that would have been funny if you actually called him a retard because he's always super nice, no matter
So
what the
the-
situation is.
So to kind of put it into perspective, his question was like equivalent to saying, "Why don't you just change the timing to what the globe says it should be?" Even though it
Because-
didn't do that.
His actual was like, "Hey, after you add in the globe Earth correction, can you take it back out so that your flat matches globe again?" Like what? We already no. That's not how it works, bro.
We have bruised ferret in the house.
Oh no, Ruhif.
Is that who that is?
The fudge packer, liar or whatever. The fudge packer.
I remember that
How you
name.
doing
I just
today?
don't remember who it is.
It's Ruhif.
Is it Ruhif?
Are you speaking? I don't know. Your mic's off or open.
No, I'm not speaking.
No, Bruce Ferret over there. You speaking? I can't hear him.
I don't even see him on stage.
I can't hear him
On
either.
stage.
I mean, I see him on
His
stage, but I don't
mic's
see him
turned off
speaking.
now.
His mic's
Oh,
muted.
there he is.
I think his mic just disappeared for a little bit.
No audio yet, Rue.
Yeah, it sounded like it almost came in there at the very beginning, but
2025 technology, boys and girls.
But yeah, we were able to make a rotary dial phone called the Moon in 1969.
let's see. It took us off the wall. Now we can't go to the moon.
Hey, and there was no delay either.
Mic check. That's better.
There he is.
There you go.
What's up for you?
There we go. All right. Should we do an example?
Sure. What do you got?
All right. The example is Jesse's observation of Blinn Mountain. Let me get the details of it. One sec. So it was 28th of May, 6:37:36 was the time, UTC, and the star was HD 187150. Let's do the example. So he is 40,962 meters away. If I go and stick myself on the peak of Blinn Mountain and turn off refraction, at that time, the star says 38 minutes altitude. What do I do next?
What was your flat Earth prediction of 54 arc minutes, or your globe Earth prediction of 47 or 41 arc minutes? Right?
No, we're doing the celestial theodolite for the flat Earth, right?
Well, 54 arc minutes then.
Yeah, so it's 600. The delta height is 640. 640, and it was 40,962 meters. That arc10.
I got 4860, but whatever. It comes out to about the same thing.
Yeah, I get 0.89 times 60. 53.7 arc minutes. All right. So the raw flat Earth angle is 54 arc minutes. The celestial theodolite gives an angle of 38 arc minutes. That seems to be a huge discrepancy.
Yep. But if you do the tangent times the same distance, 40,860 of the same degrees, 54 arc minutes, you get 642-ish meters. And you know the real height of that is 650 meters. If you do the same thing for the globe from your refracted
So where'd
triangle,
you get 54 from?
You just calculated it. You just said 5397 or whatever.
Right.
What do you
So
mean? Why
I'm
do you
just-
asking me
I'm-
where you just said that? Okay.
Yeah.
So
You
then-
basically just reversed the calculation we did to get 54. Well done.
Well, I mean, yeah, we're looking at the actual elevation of the physical occlusion of the peak. Was it at the time it was refracted? No, which is the whole
Hang
point.
on.
It was at the time where it was physically occluded.
Where does the 38 arc minutes come in then? Is that not relevant at all?
Of course, yeah, that's closer to the time.
Where does it come in?
Closer to the time. So
Let's do
like,
Pikes Peak then.
yeah.
You guys can't settle on a process.
What do you mean? We did the same exact process. That's why I made these slides. They go through the same exact process. You compare the predicted angles to the, I don't know what you're calling the Heffron angle, but the stellarium prediction, which in this case is, 38 arc minutes, or roughly 37.59. And then you say, oh, look, whichever globe Earth angle you were doing is closer. It's like within 9 or whatever, right? 47 versus 37 versus 54 versus 37.
We're talking about the angle from the top of the peak to the star is 38 arc minutes. Isn't that meant to match the raw trig angle of 54 arc minutes?
It's meant, yeah, that's your comparison
But
point.
it doesn't.
You're comparing both of your predictions to it. No, well, neither. It doesn't match neither. But then the experiment is which is closer, right?
No, because you give a fucking straw man globe prediction.
No, we don't.
Yes, you do. No one agrees with your globe predictions.
41 arc minutes for this one is not what Jesse's spreadsheet says.
Oh, don't actually know what Jesse's spreadsheet says.
Well, then how the fuck are you going to tell me that it's not the globe prediction, dude? It's exactly taken from Jesse's spreadsheet. I also did it with both of Jesse's texts. So Heffron has a different prediction for what the globe angle is, and I did a slide with that one too. That one comes out to 47 arc minutes. If you use Jesse's dependent angle with your terrestrial refraction included, I think it's 41 arc minutes. So then you're still doing tangent 41 degrees times 40,860, and you still get a lower height elevation than the actual height, which is 650, bro. It works every time. Like, I think you're probably not understanding that you'll never win if we do it this way, because the refracted angle will never be correct, right?
So the actual globe prediction is 44 arc minutes, according to me.
Okay, well then, so you and Jesse disagree, and then there is no actual archive to compare to the correct globe prediction. The way that we do it, the globe prediction equals the atmosphere on prediction in stellarium. So we have a way to double check, and you guys are off.
So the angle to the mountain?
Yeah, so if you go to stellarium, you can confirm the angle with the atmosphere on will roughly match the refracted angle that we're predicting, right? I know we turn
Does stellarium give angles to mountains these days?
No, you go to the mountain, and we're looking at the angle to the star. That's the whole process, right?
We completely disagree with that. That's a straw man for the globe.
You disagree with stellarium's prediction for the... Okay, well, that's interesting. So then you guys are truly making...
I disagree that to get the angle... Sorry?
How is that a straw man for the globe?
To get the angle to the mountain has nothing to do with stellarium.
No, I'm not talking about... No one's talking about the angle to the mountain. We're talking about from the angle from the mountain to the star, which is what we're comparing, which is what we're calculating, which is the mutually exclusive part.
Right. And we think that's ridiculous as well.
That's the method, right? I mean, you think it's ridiculous?
I know that's the method.
Terrestrial
We're
refraction.
telling you. We're telling you the method is rubbish, and it's not how it's done.
When we use our method to predict the globe angle, stellarium is a match with atmosphere on. You don't agree with stellarium giving a match with atmosphere on?
I don't agree with turning the atmosphere off or moving the observer to somewhere where the observer is not.
Well, there you go. I mean, the whole process is we're using the mountain. We're not observing a mountain. That's why we're not applying terrestrial refraction. We're observing a star. We're using a mountain as a crosshair. That mountain is an extension of our tool. We're not moving the observer to where it's not. We're using a really long conceptual fucking instrument with what we can see.
I understand what you're doing. I think it's rubbish, right? So with this Blin's
why do you think it's rubbish? I mean, we're using the mountain and pretending like the mountain's on a flat baseline and a star goes behind it, and it blocks the star, and it doesn't match up to your globe. So what part?
It does match the globe,
but it doesn't.
Yes, it does.
Be there.
Let's do Pikes Peak then. All right.
I think I've seen this in a movie once. Objection, Your Honor. For what? It's detrimental to my case.
Any peak. Continue on, lads.
I got one from Mount Rosa.
So Pikes Peak. Pikes Peak. What is my globe prediction for the mountain, Shane? Given that I told you yesterday for the 5th time. Is it 219?
Maybe we can't hear you, Shane. If you're
what?
What is my globe prediction for Pikes Peak?
I don't know. I forget.
219. And according to Stellarium, using it properly, at what angle does the star?
Means, yes. What do you mean using it properly?
Well, not pretending that we don't have an atmosphere and setting the observer to where the observer actually was. what angle does the star? What angle is the star at the time of occlusion? According to Stellarium, using it properly.
I have no idea. No one looks at that. That's not related to the
218.5
at all. Oh, cool.
218.5, off by half an arc minute.
So that is the globe prediction.
Yes,
so you
matches.
do agree. The actual
globe
time
predicts it correctly.
No, we're saying that the globe angle is 217. You're saying it's corrected to 219. That's fine.
Yes, with refraction.
The actual time of occlusion, it was 232, which is closer to 231. Yes, from the peak.
No,
it occludes
if you use Stellarium properly, it's 218.5.
You mean if you go to where you're not at the mountain peak? That's not using it
correct.
properly.
If you observe it from the fucking observing location.
Well, this is weak sauce, bro. If you go to the mountain and you look through the star, you'll get the 217, right? That's what the globe prediction needs.
Feel free to strawman the globe continuously.
The whole process is moving the observer to the mountain.
Yeah, and here's the thing: it's not a straw man of the globe, right? Because you're trying to say that the refracted position is what's being occluded in this example, but Jesse used the true position for his emergence, so he validated the.
No, he didn't.
Yes, he did.
No, he didn't. He might be testing the globe.
He used
celestial theodolite.
Listen. In testing it, right, by using the true position, he showed that it's not the apparent position, because if it was the apparent position, the star would have occluded sooner because it would have been higher.
I will bet both my fucking testicles, Alan, that Jesse and I agree.
This is what you guys have been not addressing at all for like the last couple of weeks now. So the method is based off of the raw true position and the intersection of the peak, right? Not the apparent positions. For every example, you guys are like, oh no, but if you're at the observer location, moving it to where he is, then the globe refraction is the explanation. In other words, you're saying that refraction is making up the entire difference every time, but the true position was used for Jesse's example.
Jesse may have been testing the celestial theodolite to say it can give a flat Earth result or it can give a globe result, showing that the method is rubbish. But his actual globe prediction is setting the observer to where the observer was and leaving the atmosphere on. Betting both testicles on it, Alan. Both of them.
I went into Stellarium and verified it, dude. And I asked him directly. I was like, you used the true position, right? And then I went and checked. He did.
Yeah. Under the assumption of a celestial theodolite being a valid method. And he's showing that it's not.
Bro, you can assume whatever you want. The star didn't emerge earlier. It wasn't the celestial refraction correction wasn't lifting it up above before the true position. So like what you're saying is just pure rhetoric.
And wait a second. Wait a second, Ruhi. Aren't you the one with my 7/6R buddy who says never compare observations below a certain threshold? But like this observation that Jesse did is 600 meters above sea level compared to 3,500 and 4,500. It's so tiny. The triangle looks like a little thimble. It's barely even a triangle. So when we're calculating angles almost on the horizon, isn't that where refraction is strongest anyway? So isn't that where the flat Earth and globe predictions would be less discernible from either one?
The point of Jesse's...
How is it not? How do you disagree with that? That's one of your premises. You tell me all the time. That's why I stopped arguing observations on the surface of the Earth with you, bro.
Right. And Jesse's isn't even closer when you backwards derive the distance. Did you get that part of the situation too? That there's two separate triangles involved in this?
You guys claim to have eliminated refraction, which is rubbish. Right. So
we apply
again, I tried to walk through the example.
Rue, can I explain something to you real quick? We're not disregarding refraction, right? We even give examples at the beginning of the Cell Theo presentations where the occlusion time is still going to change, because once the physical intersection happens with that point light source, it's no longer going to be refracted. So the refraction between the star and the mountain peak is totally a thing, but it's still going to dictate a different time. And your time can't always be, it's the exact amount of the difference for the flat Earth prediction. That's preposterous. And then on top of that, Jesse used the true position for his measurement.
So Blinn Mountain, where is refraction coming into the flat Earth celestial theodolite? We have a delta height. That's nothing to do with refraction. We have a distance, and we have an angle to the star with with atmosphere off, and we get 38 arc minutes. Where is refraction?
Can you refract an occluded object or an occluded visual effect?
Yes.
Can you refract that?
We
Can you
literally-
refract it once it's occluded?
Yes.
We literally start with demonstrations showing that that's not true. One with Taylor with a cup of water and a knife and a laser, and the other one with Goose with the jig he made, where when you add the refractive medium, the occlusion angle is measured different. When you line the stick back up, it's literally a different angle. So you have to have a different timing. It's a
I
point.
haven't looked at those.
Oh,
the
so I'll send them to you right now on Telegram.
Cool.
Because it's extremely pivotal to the argument, and especially given that Jesse had to use the true pause before the star was visible rather than the refracted pause.
Yeah, both testicles on the line, Alan, for that. Anyway, the path of light, whether it gets blocked by anything or not, is curved. All right. So
agreed.
The path of light from the star is curved all the way, but the mountain gets in the way. Right? It's a curved path is blocked by a physical mountain. It's not like when it gets blocked, everything just goes back to straight lines.
Your conclusions are premise.
What?
I just explained that to you. I agree.
We fundamentally just no, we don't. Why are you using straight lines for
there's refraction between you and the mountain, but even still, when there's a physical intersection, there's an occlusion. So you still need a time that is your own. You don't get to have our time. And I'm sending you the physical occlusion stuff right now and also acknowledge dude.
So Shane, when Alan just said I need a different time, have I not shown you many times a screenshot from Stellarium with the time set at the actual occlusion time recorded, showing that 39 Aquarii being occluded right on the edge of the mountain? Have I not shown you that?
When you move the observer to where he's not on the mountain?
Where the fuck is the did
the mountain,
Mike Heffron observe from?
You put the coordinates into Stellarium for the mountain. You're using the mountain as the occlusion piece. Like, you're not looking at the mountain. You're using the mountain, dude. This is the whole process.
Again, why do you keep strawmanning it? No one agrees with you.
That's the whole process.
We're
to tell him that that's not his process.
Yeah, we're externally testing the
internal consistency of your model, dude.
Yes, that's it. Thank you, sir. The internal consistency of your model, right? That's why you want to move the observer and say, look, it's the refracted position. But it's not. It literally the true position lines up closer when you backwards derive the elevation based off of the occlusion timing every time. Like, we don't need J factors or anything like that. Shane has taken all the observation, or not all of them, but he's taken a number of them so far and converted them all into nice little pictures there that have simple trig formulas that show the comparison and how the globe is off. And it's like, for this one example that you guys are trying to use, you actually had to use the true position, and the elevation is still closer for us.
I do recall back in the early days of the celestial theodolite, I think it was Beatrix, but maybe it was Piso, whatever. Someone was hassling the shit out of me to steel man the celestial theodolite. And they got really shitty when I said, you move the observer to somewhere he wasn't, on the mountain. Right? And did I get booted out that day? I think I did. Anyway, can you guys steel man the actual globe position for Pikes Peak, say?
Yeah. You got what we do, plus you add terrestrial refraction per kilometer.
Oh, hang on. Don't just say what we do.
Yeah,
that's leaving out a whole bunch of shit, right?
You use your delta height to get your arctan rise over run, so it's a lower height than our arctan, and then you start with that as your base prediction, and then you add in both celestial and terrestrial refraction after you correcting
just to the mountain.
Okay.
What's the angle to the mountain on a globe to Pikes Peak?
Well, it's never part of the formula here. It's not even on the slide.
You're steel manning my position, Shane.
Well,
what's my position?
What we only need to produce your timing, and the actual position is you produce 219.
Shane,
that's your position.
What's the globe prediction for the angle to Pikes Peak?
The angle to Pikes Peak is not your angle, dude. The angle is the angle that you gave me, 219, that you just said was your angle when you said, what was my angle, Shane? And you remembered, and you told me, we went through it just today. And we know that now it's 2 arc minutes different than what we are showing on the slide, right? We started the conversation that way. So are you saying that's not your angle?
My angle is 219. Right.
Yes.
So you agree that my prediction is 219. That's your
Yes.
steel man. Right.
Yes.
What is my steel man for the angle to the star at the time of occlusion?
I don't know. It's irrelevant. I've never
218
thought
and a
about it
half.
once because it doesn't
218
matter.
and a half.
It's not relevant in the prediction. It's not
So you
relevant
can't
in
steel
the
man
mutually
it.
exclusive angle.
You can't steel man it.
Well, I mean, I know that
Massive
you need to
hypocrite.
include it. You need to include it, but I never listen when you do because it's not relevant to like whenever you start
I'll just
talking
call the
about the
celestial
optical
theodolite
angle.
irrelevant.
Whenever you start talking about the optical angle, like we try so hard to get you to see that it's not needed, not required, not part of the math, not used in the process, not used in any of the predictions that we're using it. So whenever you bring it up, we're just kind of like, oh, all right, great. That's not the. So when you say what is my prediction, I'm like, I don't know. It's not part of my spreadsheet. It's not part of any of the data set that we're using to make any of the predictions. So why would I know what it was?
Right. So you acknowledge that you can't steel man my position.
You don't have a position on
Hey,
this, man. It's not.
I gotta go. I just want to say this really fast. When you keep saying that we're straw manning the globe itself is a straw man. You have all
bro.
these exact numbers, and all we're doing is falsifying them.
Okay, bro. So is my position, Shane, that the mountain is 219 and the occlusion happened at 218 and a half?
So you can't get the occlusion happening at a completely
can't do
different
it.
time. Yeah, you can't just say you have a different process to steel man your process. The occlusion happened at the time Stellarium says it did, right? Are we not even agreeing on that as a metric? That's preposterous, dude. Yeah.
No, I've set the time to the
Jesse
occlusion
seems to
time.
agree with it because his whole spreadsheet has a column for Stellarium and everything is based off comparing to that value. So it seems that Jesse agrees with me. What happened to both your nuts though?
Yeah, let's bring Jesse in. Where's Jesse?
I'd rather give both my nuts than do that, to be honest.
Okay. Yeah, Jesse's not here to give his information, and I don't have that information right now. So I can't respond to that. But I know that Jesse thinks the celestial theodolite is bullshit.
Yeah, we all know that.
Is that I'm waiting for an actual argument.
Who's Jesse? Why do we care
Yo,
if Jesse thinks it's bullshit though?
So far, I disagree with your methodology of externally testing my internally consistent system. Is all we've heard so far.
You're straw manning the globe position, yes.
You're saying that your angle is 219, but then you're saying in your steel man you actually have a totally different angle from a totally different prediction from a totally different place, and that's somehow relevant. That's your position.
No. From the observer position,
yes, dude.
The angle to the mountain is 219. From the observer position, the angle to the star at the occlusion time is 218 and a half. Very close.
So how were we setting up this this experiment wrong? Because it's supposed to be trying to eliminate the null hypothesis of a flat Earth. So what are we doing wrong on this that makes you want to keep on talking about a globe on here? What part aren't you getting there?
Rubbish.
You do realize this is a null hypothesis, right?
Oh,
right. But the method
the day the globe died or whatever.
Jesus, bro.
Rubbish.
The method to falsify the null hypothesis has to be valid.
Well, we have a mountain peak, right? And we're like, what, 57 kilometers away, and we're saying this is a flat baseline, and then the star goes behind the mountain and gets blocked, and we're saying that matches up with a flat Earth because that mountain wouldn't be there if it was curved.
That's just incorrect. The angle question, which I posed to you guys last night in a
that is absolutely
a YouTube
correct,
post.
Bro.
Posed to Shane Allen.
Oh, sorry. Go ahead, Rue. My bad. Go ahead.
Yeah. Posed a question, right? So we know that Heffron got that actual.
Oh, your poll. What does potato mean? I almost voted potato, but I didn't really want to vote because I don't care about the angle, right? That's the whole point.
But you won't answer though, will you? At what? Given that he measured the angle. Given that he measured the angle to the peak at 218 during the day, right, and then he sets up his camera, like his C-star, whatever, and captures star occlusions, at what angle is that camera actually pointed at nighttime?
In my example, there's no way to tell. It's irrelevant, and the dude only has a video camera.
There's no way to tell.
Well, in my example that I redrew to break it down to the most simplistic view, there is no theodolite. He actually has a camera. So now I'm going to call it the astronomer's plumb line. Okay. So now he's got a camera and he's got a chronometer, and that's all he knows. So the only observation he made was what time the star went behind the mountain. He has no ability to tell what angle that was. That's how irrelevant it is.
Are you saying you can't measure the angle?
I'm
you
saying
serious?
in my
Wait,
example,
wait. Before we get to measuring the angle, right? Because that's not, we don't disagree that you could optically measure that, and that's what the globe predicts, et cetera, right? We're good. But let me ask you this. Do you agree that angles to stars in time are interchangeable on the globe, right? So like a star will be at a specific location at a specific time, and that, like, if you know your time, you can figure out the angle and vice versa, right?
With refraction, it complicates it, but overall, agree. Yeah, agree.
Sure, yeah, absolutely. Okay, so with that process and relationship, right? That all started with a baseline snapshot called the first cusp of Aries. You're familiar with that, right?
Yep.
Okay, so they took the apparent position of the star zenith measurement and they just added 15 degrees per hour to it uniformly, essentially, right? Just to like explain it briefly, right? So we're taking that as the true calculative true position, and at the time that calculated position, because like we can't adjust anything or change anything, it's just time, right? With respect to where a star once was, and that angle is lining up when the star is no longer visible and or when it emerges, or it'll be a scenario where when you backwards derive the time in which the one of those two events happened, the elevation that you get is more closely corresponds to the occlusion being caused by an object that was on a flat earth.
So when I said refraction complicates it, let's take that out for a second. In Mike's spreadsheet, right, he has the RA and DEC of all these stars and, works out the sidereal time, blah, blah, blah. That geometry that he uses in the spreadsheet to convert RA and DEC into alt-az, guess what that means the Earth is?
Absolutely not, dude. Converting right ascension and declination is just what Alan said. It's just relating time to the stars, dude, right? That's the sidereal rotation, 360 degrees, so you get 15 degrees.
The formula is a spherical formula. It converts your position on a sphere into an altitude azimuth.
Okay, Bruce, Ferret, Ruhif. If you go into Stellarium, you can view the stars in equatorial mode where they go beneath your feet, or you can view them in azimuthal mode where they do an arc around you. So the cosmology,
they also go on your feet.
The cosmology of that is not mutually exclusive.
Sorry, did you say that alt-az doesn't go negative?
It goes,
what do you mean?
Around you.
And underneath you. What are you talking about?
Hold on 1 second.
Bring up Stellarium, set it to the middle of the night. What's the altitude of the sun? -90.
It doesn't show you anything beneath your feet. It shows you level ground. It shows
right,
you
but
just
if you turn the ground off, you'll see the sun.
Yeah, right. The equatorial makes it rotate around the prescribed poles of latitude and longitude. The azimuth puts it right above you, and so it rotates in your actual zenith. But it also turns on the ground so that you can only see half of the hemispherical sky. The point is, observing it in a hemisphere is equivalent to spherical coordinates. All you have is that negative z component, but it's based on the circumference value. So if it's really rotating around a circle and it's going in and out of your view at the same rate, you have the same predictive power with hemispherical as you do with spherical. That's the contention. That's why it doesn't matter.
I thought the claim was that they don't go negative with the alt-az view turned on.
Is
that not it?
The claim is that the negative value, the contention is that the negative value, whether it's above you, like, always, but it's just out of your field of vision, but it arcs away at the horizon to where, the same effect optically as if it was Earth curve, that's the same. But if you were going to map it out mathematically using that negative function of not being able to see it, would be represented by the same thing. There's no change. And that's what we were pointing out with Stellarium.
Right, but do we agree Stellarium definitely shows you objects going underneath the feet?
Yes, but do you agree that it also doesn't do that too when you do the other option?
What? No.
All right.
At all times, there is half the celestial sphere below you at all times.
I think we could talk about some Buddhist cosmology right about now.
Well, I think we've done a nice summary of how we established Pikes Peak definitely proves flat Earth. You know what else does? Mount Rosa. You know what else does? Blue Mountain. Berlin Mountain, though, we found is inconsequential because it's at such a small angle that differentiating flat and globe is tough to begin with. So that
16
actually
arc minutes.
the elevation you come out with actually is much closer on the flat prediction than it is the globe, because you can't have your refracted cake and eat it too, as they say.
16 arc minutes is a win for the celestial theodolite, really?
It's for Jesse's observation that can't be replicated with different elevations for each observation at the same peak. Yeah, that time corresponds more closely to the globe. But again,
hold up.
It's much smaller than any other elevation at 640 meters. That's like what, 20% of what we're looking at, and its actual angle isn't even a full degree. It's so close to the horizon that it's nonsense.
Slow down.
His
You
video
keep
is
saying
retarded,
shit
dude.
that has to be corrected, right?
All right, go ahead.
Okay. So when you say Jesse has changed the elevation of the peak in certain areas, you would have to acknowledge that Blin Mountain is not a perfectly flat top mountain, and he's changed. Okay, yeah, he's changed the elevation given that the angle sort of slopes away, and he's changed it by what, I think 3 to 4 meters, something like that. Is that right?
Well, conversely, when Mike tried to do the very same thing, you made a whole video about it called the fudge factor and put a whole fucking gay fudge factor thing on it, right? So that started a whole lot. So changing the elevation because of what you're thinking, like that's what he called out Mike for doing. So why is it okay for Jesse to eyeball shit and change his elevation at the same time?
No. Did you not get the point of the fudge factor video? Do you want in a single sentence? What is the point of the video?
That none of the observations matter because the timing is irrelevant.
Correct. 100% correct.
We're not adjusting the time, as you saw in any of these observations or the discussion.
Yes,
There's no adjustment made. No, we're not.
What the J factor is the number of seconds between the occlusion and then the
we don't need that in none of the slides I sent you. We talked about this the other day on Telegram, and I specifically told you that there's no need for it. It's a supplemental analysis that is not needed.
Why didn't you say that in the stream yesterday, Shane, when Heffron was talking about J factor?
Bro.
Well, he likes his correction to his data, his aggregate. He built it into the spreadsheet. His spreadsheet has a button that toggles it on and off for the user, bro. Like he talks about.
But why didn't you tell him that it makes the whole observation? You may as well have stayed in your basement and not make an observation at all. Why didn't you say that?
Well, it doesn't. It cleans up the data.
Yes, it does.
Right? It gives the glow. I mean, I understand your contention with it, which is why we turn it off when we do our comparisons, and why it's not needed in any of the discussion we've had so far, nor the examples that we point up, nor in any of the math that we're talking about, right? We're not talking about an adjusted azimuth elevation. We're talking about our predictions based on trig and what we're doing for corrective globe terrestrial celestial refraction, bro.
Okay, I have the screenshot from Alan, right? That says you put the time into stellarium, and then you let it play out until it reaches the globe Earth angle for the elevation of the star. All right. Do we agree that time, whatever it is fixed and won't change?
What? What do you mean let it play out?
That time.
That is,
right?
1 second. That was the process or whatever that he gave to reproduce coming up with the calibration for the J value. But again, we don't need it and don't care about it at all. Like it means nothing.
But why didn't you say that yesterday?
We've said it all that we say it all the time. He was telling the guy specifically asked him about it, bro.
It was part of the question.
But why didn't you say it may as well be not making an observation at all?
What?
I sent him your video. Maybe he watched it.
The J factor. Well, then why didn't he say it? If you have this J factor, you may as well have stayed at home.
Nobody has the J factor, so we're still here.
Okay, but why didn't you say that?
So there's no J factor, though, and you're completely changing the conversation to divert from the fact that the one observation that you have was completely cooked, where the angular difference is the same as the refractive correction. And on top of that, no one can agree on the elevation of the mountain, and you're just eyeballing it, adding 10 meters for trees here and there, subtracting elevation meters while trying to ask us about why we didn't question Mike on his shit, dude. Get the fuck out of here, Rue. You're fucking losing it, bro.
When you say something wrong and then keep talking for like the next 10 or 15 seconds, I have to interrupt. I'm sorry. When you say we're just eyeballing it, no, we're not.
You can't remember 3 things to argue against, bro?
When Alan said we're eyeballing it, no, we're not. And we showed Alan how we determined the height.
He said, quote unquote, I drew a line in Google Maps to the 3D tree. Bro, that's literally called eyeballing it. You're adding 10 meters for a tree at 40 kilometers at something that's less than half a degree at the horizon, dude. Like you do you, man.
And what did I send you?
Don't care. Didn't even read it, bro.
Okay, there we go. I sent you. What I did was actually measure the angular separation between two stars in the frame to get a scale for the snapshot. And then we had the FCC height of the antenna, and I scaled that down to where the trees were using that angular scale.
Fantastic. And I found four
So we
separate
didn't just fucking
references
eyeball it,
of,
did we, Alan?
I found 4 separate references of different elevations. You can do the custom method to adjust whatever you want, dude. You guys criticized Mike for the exact same thing. And we're not even yes, you came up with your own method to eyeball it and custom adjust it. That's exactly what you did. And that's exactly what Okay, then Mike didn't eyeball it then either, did he?
I don't know what Mike did. What are we talking about?
Yeah. Oh, word. Good dude.
My God.
We're talking about Blinn Mountain. We didn't eyeball it.
To be fair, dude, I tried to replicate what Jesse presented in the spreadsheet, and I couldn't do it. And also, to be fair, I could replicate every single one that Dr. Mike did. All of the elevations with Dr. Mike are consistent. All of the data from Stellarium is replicable. If you go to the same time, you find the same angle. For Jesse's 4 observations, I could do it for neither, not one. I just took his word for it on all of it. Right. And that's so sketchy. So, I mean, just saying his video was retarded. If Goose didn't help him identify a star, I wouldn't have seen one thing actually come up in Horizon. James, it's so comparison to
Are you going to tell?
Retarded. Sorry.
Are you going to tell Heffron that the J value makes it meaningless to make an actual observation of the occlusion timing? Are you going to say that to him?
I told him that it's unneeded and gives people a thing to latch onto to invalidate the whole process and should be omitted. So.
Pretty weak.
Whatever.
Pretty weak.
Okay.
Why is it called the J factor again?
Hold on a second. So, like, you disagree with how we've told him that it's not necessary and we don't care about it? Like, you want us to be, like, more different about it? Like, dude, your point of contention is weak, dude. We have actual measurements that falsify the globe. And you're talking about, I don't like this thing on a spreadsheet that has a toggle function that is clearly not even needed to falsify your point, but I want to, like, harp on it.
Right, but you've got Shane and Whitsett saying this matches Flat Earth perfectly because they've turned the J factor on.
It doesn't match perfectly. It matches.
Well, it does it with the J factor, right?
And that's true, but that's not really what I meant when we say perfectly. We just meant on every single observation, it's closer to flat than globe. That's what I mean by like the data set is perfect.
And what's the J factor?
It's the fudge factor. We can go into that if you want.
Yeah, but when we went through the slides, like arctan rise over run for any of these observations doesn't include a J factor. My angle for Pike's Peak of 232 doesn't include any sort of J factor. Your prediction of 119 doesn't include a J factor. The comparison of those two angles to the actual occlusion of 232 doesn't require a J factor.
No, the actual occlusion is 218 and a half.
Oh,
the
so
actual
you disagree on the premise
218.5.
of the entire observation. Back to this. Okay.
Yes,
I disagree with your bullshit. Yes.
So just to be clear here, like the only way to argue against the Cell Theo is not to accept an external.
No, the way to show it's shit is Blinn Mountain, which is what Jesse aimed to prove.
No,
that's what we just dissected and speculated on and did the corroborative data that I told you I couldn't replicate it. You know, I tried really hard, dude.
What do you disagree on? Do you disagree on the delta height of like 640?
Well, the height, no one knows actually what the actual elevation of Blinn's Mountain is because it's that
let's
small
give
hill.
You 630 then.
Well, everyone used a different elevation, and Jesse's spreadsheet has different elevations for each occlusion. That's right. Our contention, right? That's retarded.
But by how much?
I don't know, 5 to 10 meters. 25 meters is the spread, actually.
Yep. So let's go forward with that sort of plus or minus in mind. Right, we agree roughly on the distance, either 40.8 or 40.9 kilometers. Cool.
And I don't know actually what star was actually being included. I couldn't replicate that. Goose said that he did. He said that it was this star, HD 187663 or something.
187150.
Yeah. Well, that's he did 4 occlusions, and that's a different star.
So you disagree with the star. All right.
No, I just said I couldn't find it and I couldn't replicate it, and I don't see it in the footage, to be honest. It doesn't look like that star to me.
Wow. Okay.
Because
All
his
right.
footage is so terrible. I can't tell, to
So-
be honest.
So let's go forward with that, possible variation in the height, and assume that the star is the star that we've identified.
Yep.
If I
I'm
look at
gonna-
that star in Stellarium, it gives me 38 arc minutes. All right. The
need to
raw
look at
trig angle is 54 arc minutes. So either the celestial theodolite is fucked, or it's the wrong star. They're the two options, right?
No, it's not fucked. It's at a tiny distance, at a tiny elevation, at an angle just above the horizon where refraction corrections are so strong. In fact, for this prediction, the drop over distance is 22 arc minutes, which is a correction to our angle. The GG Bennett
Sorry, what?
celestial, the GG Bennett
22 arc
celestial
minutes.
refraction is 25 arc minutes. So that the actual difference between those two, which is how we get our prediction of 47, that's how that's determined. It's so this spot is so close that the Earth curvature correction almost equals and offsets the celestial refraction correction, so that it's closer to the flat Earth baseline, which makes it indistinguishable between flat and globe. That's why this is a cherry-picked observation.
How much is the terrestrial refraction between Jesse and the mountain? Did you say 22 arc minutes?
The celestial, no, 25 for GG Bennett.
No. For to the mountain, just the terrestrial refraction. Terrestrial drop. Sorry.
22 arc minutes.
That sounds like an awful lot.
Yeah, Jesse disagrees, and he says it should be 11 arc minutes in his specific application because it's twice applying the central angle over the drop over distance versus the dip angle. But what we're doing is using both of those concurrently, right? So we're using a negative for the drop over distance and the GG Bennett for the to add it to the central angle, to add it to our flat Earth angle. If you knew the process that you were refuting, Ruhif, you would have been able to identify the basic steps in obtaining what is actually the Heffron angle, bro.
Hang on. So over 41 kilometers, the drop is, refracted drop 113 meters. So distance. Oops, size, not that one. Angle. Yeah. So it's about a sixth of a degree, 10 or 11 arc minutes. Where do you get 22 arc minutes of drop from?
We're adding it and then subtracting it. So we're doing it a different way. So we're using the geometric arc angle, and you're using the optic dip angle from one side, which is half. So if you look at the geometric application of this, which is 360 times the distance over 2 pi r, then this would overestimate at small angles, right? Which is what this is, a really tiny, small fucking angle, and it's only a problem here. So our prediction,
it's not 226 meters of drop.
Dude, what is your globe angle? Just tell me the globe.
Hang on. It is 44 arc minutes.
Okay, I had 47. His Jesse spreadsheet says 41. So Jesse has 41 arc minutes. You have 44 arc minutes, and we have 47 arc minutes. You see how it's problematic when no one can actually confirm what the globe prediction is outside of an outside reference?
I can't see Jesse's spreadsheet.
Well, I'm telling you, I'm looking right at it. It doesn't matter. All of those are wrong, right? Because the actual time is 38.
But is he doing something? Is he doing stupid celestial theodolite shit to get 41? I don't know.
Jesse, it was Jesse's prediction, the way he got all his other predictions.
No. Jesse is doing two things.
41 is closer to 38, right? That's what his point is. It's like within, it's very close, way closer than 54.
Right. So he's probably doing the first thing, which is saying, let's grant that the celestial theodolite is valid. Here it is showing a result that's closer to the globe, right? That's different to saying my actual globe prediction without all the bullshit is 44.
But you're dismissing that if we reverse this, right? So the tangent of 54 arc minutes times 40,860 meters is 642 meters, which again is 4 meters.
That's how you got 54 arc minutes, right?
Height. Well, that's what we did, was predict the actual physical time of the occlusion and then estimate the physical elevation of that peak at the time of occlusion. Since you're locked into using a refracted angle as a prediction, then you have to obviously take the tangent comparatively of the smaller angle, which obviously underestimates the elevation of the peak at the time of occlusion. And using Jesse's own prediction, I did it for 47 arc minutes. You got 558 meters for that peak, which is 87 meters off. So we got 4 meters off for flat Earth using Jesse's prediction and Jesse's observation, and 87 meters off for the globe using Jesse's observation.
So what you just did is you went 41 kilometers times the tangent of 54 arc minutes, and you got 640 meters, right?
Yep.
Where do you think you got 54 arc minutes from?
The arctangent of the rise of the sun.
Right. So
when
you
we
just
were
reversed. You
predicting-
just fucking went backwards.
Well, I mean, it is actual physical occlusion with a
Jesus
physical
Christ.
prediction, right? So when we say it's going to be at the physical time, then it couldn't possibly coincide with the refracted tangent. Now, could it?
You've literally gone 1 + 2 is 3, but 3 - 2 is 1. Aha. Like, it's fucking retarded.
The elevation for your prediction angle is fucking retarded, dude. It's lower than where the peak is. It would have to be, yeah.
44.
So that's
Yeah,
how Jesse.
I was about to say, speaking of convoluted things, how did they do their prediction again?
Which prediction?
Well, so instead of using the rise of the arctan over the run, the arctan rise over run, what you did was arctan of delta change in distance from the difference in the geometric earth drop of rise over run from the elevation times where the observer is.
Sorry. Right? To get a prediction for the mountain.
For your globe Earth, you took the Earth curvature drop, you subtracted it from that initial height, and then when you subtracted the observer height, you took the tangent of that to get your quote starting angle, right? That's a way different method. That's a way different method than what we're doing, which is why you're disagreeing. But you notice that ours comes to a consistent and cohesive answer that can be double checked and still in with atmosphere on.
Except for Jesse's, right?
And yours comes to a completely different thing that nobody can double check that you disagree with Jesse on. So.
Well, again, Jesse's not here that we can talk to, so it's hard.
Well, it sounds like this is fucking retarded, to be honest. But we'll give you the benefit of the doubt, and we'll pretend that this is a closer to the globe observation, and we factored it into our spreadsheet and data anyway. I don't think we could ask for more.
It's not. Doesn't matter that it's closer to the globe, right? This is a test of whether the celestial theodolite is a valid method.
The entire purpose is whether or not it's closer to the globe. How are you going to tell us what our fucking thing is? That's crazy. That might not be your thing, but our thing shows that it's not closer to the globe.
You're trying to beat
our
the
thing
hypothesis of a flat Earth, Ruhif.
Right, and to do that, to be able to falsify it, your method has to be sound.
All right. I feel your objection to that, to the scientific method, right? It has to be accurate and statistical accurate everywhere. But your other main position, Ruhif, that you're known to hold is that refraction at closer to the Earth's surface makes it harder to distinguish flat from globe. You say it all the time. It's part of your major discussions. It's your favorite thing to present about with 7/6R and your weather balloons and your atmospheric data from all the airplanes. You talk about it incessantly. So how can you then say the example to prove the method is null is this other example of a really low elevation, tiny angle closer to the horizon than anyone ever needs to measure to prove that actually this whole method is null? Is that not disingenuous from you?
Yep. No, that's fair. I mean, we can get Jesse to repeat it with a higher elevation. That's fine. What I would say in response, though, you're aware that. Hey, you're aware that Bo BMLSB.
You realize. Hold on a second. You actually realize. Wait. I have to correct you when you're saying something wrong. Check this out, Riff. You actually can't, because if you're above sea level at a certain point, the celestial refraction is never going to be equal to the expected globe drop. Like it's literally only a specific ratio when the observer is at sea level where it's most likely to occur, because that's where you get the most celestial refraction correction. So GG, dog. Anyway, continue.
Didn't follow that. Anyway, so
you didn't follow that. I'll say it again. If you're at sea level, there's more celestial refraction corrections. The formula and exact quote from Jesse. Hold on, let me just read the quote from Jesse real quick. Give me a second. We can just do that. Go ahead and continue.
All right. So Bo from BMLSB 69 went to that spot for about 90 days and probably went, 70 days out of 90. One of those days, he got the black swan. Right. So my argument is not that you can never trust low observation angles, but it could be an anomaly what you're looking at. Right. So, it's probably 90% confidence interval or something for Jesse's observation. If he goes out and do it again, it then becomes like 99% and then 99.9. All
right. So Ruhif, I asked Jesse to find me an elevation at Pilot Peak using his simulator where it would work, and he said he can't do it. And I asked him why. He said because it's too high compared to the observer. The observer is too high above sea level. The higher elevation angle and the lower atmospheric pressure, the less astronomical refraction there is. The method relies on turning off astronomical refraction to get globe results. So to get the elevation angle too high and not big enough is not big enough of a change is made by turning off astronomical refraction to get it lower. Do you understand it now?
I think what he's saying is to, like my original video was showing that there needs to be a specific combination of delta height and distance. I think he's sort of reverse engineered saying there needs to be a specific combination of drop and
That's
celestial refraction.
exactly.
Similar, yeah.
Exactly. So
That's exactly what it says.
the angular different, like the expected drop angularly for the globe has to be the same or similar to the celestial refraction correction. So that's why when you go out to the horizon at sea level, 600 meters above sea level, right, you're going to get, that's where the 25 arc minute correction comes in for celestial refraction. That's why it's so extreme.
He's saying these numbers need to match for it to fall into the sweet spot, which is what I said in the video.
Which is why we said, hey, you guys are cherry picking it. Why are you doing that? And you guys said, no, we're not cherry picking it. And we said, well, then why can't you go anywhere and do it? And you said, well, you didn't say anything specifically, but it was presented that Mike was cherry picking it from his freaking house that he bought 11 years ago. Like that's so preposterous.
No, not at all what we're saying. We're not saying Mike's cherry picking his observations. We're saying he's discarding Jesse's. That's cherry picking.
No, nobody's discarding Jesse's. We have a spreadsheet. We have it. What? Nobody's discarding it. We literally just went. What? We just went over it with you. There's a freaking thing that
38 arc minutes is where the star's at. The raw FE angle is 54 arc minutes. You guys ignore refraction, so that's not a factor.
That's true, but again, 644 meter predicted height, 4 meters off the actual elevation, and you're 87.
You don't, Jesus, Shane. Does anyone in the audience understand what Shane just did?
Yes, he backwards derived what the rise is by the occlusion angle and the distance.
What he did was he went the arc.
Yo, is that not what I just said, brother?
Do you understand that it's trivial? It's circular.
No, because listen. It's not. Listen, I'll tell you why it's not circular. It's an entirely separate triangle based off of a physical occlusion time. If your time, because angles equal time. Yes. What do you mean? So the star is still visible? Like that? What do you mean?
He used 54 arc minutes.
All we have is the time the star wasn't visible, bro. That's all we have.
Which is 38 arc minutes. 38 arc minutes.
Which corresponds to an angle.
38 arc minutes. Use that, Shane.
What time was it occluded at?
Hang on.
What angle was it when it was occluded?
38 arc minutes coincides with the exact height of 650 meters. So
no, it doesn't. It's like 450.
What do you mean?
If you go 40,962 times the arctan of times the tangent of 38 minutes, you get about 450 delta height. Not 600 and something.
No.
You're 200, almost 200 meters off.
I'm using my wrong predicted angle.
What?
Right? I'm using my prediction of 54 arc minutes. Why would I use the actual?
That's not your prediction. That's what you did. Is you went 640.
Rise over run is the prediction. Dude.
Right. Yeah, 54 arc minutes, right? Yeah, and then you just went, what's 40,000 times the tangent of 54? Literally 1 + 2 = 3. 3 - 2 = 1. That's literally what you did.
To compare the physical height with the time of the occlusion, and comparatively your refracted height, which is always lower and will forever be wrong.
Where does 38 arc minutes come in?
That's what we said. It's closer to the globe than flat.
So it's 16 minutes off?
Well, I also, like we said, it's a tiny elevation, it's a tiny angle, and it's where the refraction and the curvature drop.
You guys claim to have eliminated refraction.
Using the physical occlusion time.
You guys claim to have eliminated refraction.
Yep.
It's 16 arc minutes off. Is that a win for you guys?
No, but the elevation still
so it doesn't work.
This one, like we said, that no one can replicate, that can't find in Stellarium with different elevations.
With refraction on, Stellarium predicts the star is higher than the peak, so it should be visible sooner, and it's not. So even still,
hang on, I'm gonna put Jesse over on the. There we go. Cool. All right. So I get 42.5 arc minutes for the star.
Okay. And do the tangent of that times 40,860 or whatever.
Yeah, that should give you the delta height, and then you take off refraction and stuff.
No, we're gonna use your final prediction as a tangent to get the height of the so-called triangle at the time of occlusion. That's what we're doing with the last part.
Yeah, and then account for refraction and drop. Yes.
Oh no, you've already done that.
Dude, what?
What do you mean?
That's what that's how you got the angle. You accounted for all of that in the prediction and drop. That's why it's different from the flat Earth prediction of 54 arc minutes, right?
If you don't account for the drop, then all you're getting is a flat Earth elevation.
You already accounted for
and it's going to be wrong by the amount of drop.
Right now, man. It's set up on a flat Earth elevation.
Rue, all we have is the angle and the distance. The angle of occlusion based on the time it was occluded and the distance. So now we're just going, hey, hypothetically, right? If we were to backwards derive the elevation required to make such an occlusion, would it be closer to a flat Earth or would it be closer to a globe?
Yeah, it's the globe. It's a minute and a half off the prediction of a globe.
Elevation converted into meters.
Yes, it'll be at 635, something like that, thereabouts.
Well, that's higher than 558, but it's not closer than 644, which is where we're
at. But this is to the left of the peak, right?
Well, I don't know what elevation.
Dude,
dude, elevation for the star. Like, I don't know if you want to change that now.
And keep in mind the actual Heffron like method, right? Like, not talking trigonometry right now, like just talking like actual method, is to use a mountain peak because this removes ambiguities where you have to like introduce your own analysis to adjust for the elevation things and make it ambiguous. So like just a heads up.
You're saying that every observation so far has been perfectly on the azimuth of the peak?
No, I'm saying they've all been, our predicted elevations have been 50 to 60 meters off, and then the globe corresponding predictions have been 150 to 250 meters off.
That's not what I'm saying, Ruhif, but I'm saying like moving forward for people listening and stuff, like ideally you want to be able to try to have your device centered directly on the peak so that when you get the occlusions, you know, the elevation is more known because you're not, you know, going down a slope and whatnot. Just throwing that out there.
No, I agree. But like let's say a star sets, you know, a little bit to the left, then it's not going to be setting at the same elevation as the peak, right? That's obvious.
Yeah, the less obvious way is how do you account for that precisely enough to make your actual adjustment to your data and call it scientific?
Yeah, see, you guys,
like I said,
you guys disagreed with the J value, and we disagree with manually going through whatever you did to do it. Same thing.
Yeah, but I think
scaling
have him do it again. Have him create his same situation at a respectable elevation, and then we'll reconsider this.
So like above 1 degree or 2 degrees or something?
Yeah.
Okay. Yeah, I'll do that. That'd be fun. I'll see. I won't get any chances to do it.
Threshold. Yeah.
I got fuck all around me. What else going to say? The J value.
Yeah, there's got to be something you could do in the South, dude. Or you like how are you all of a sudden out on this one, bro? You can't go nowhere. There's no Southern lads. Isn't there another guy?
To get a spot to a star setting behind a mountain, probably an hour drive, maybe more.
You should do it for us, bro. It would be super significant and nice, man. It would be much appreciated if you took the time to do that. It'd be super dope.
And don't do it
keep
like
asking my daughter to go for a road trip, and
don't do it like a snake. Do it like a real person. Like don't be like Jesse, or whatever.
I was gonna say the J value.
Yeah.
You guys are aware of Jesse's cloud hypothetical, right?
Yeah. Are you aware that we don't use the J value, or like I never met her before? Like you understand, like I don't.
Hasn't been part of any of our.
That's great.
It just seems really weak that you won't tell Mike.
We've literally told him, and you're dude.
He was
I
still defending
politely
it
said that
yesterday.
I disagree. Dude, he's allowed to defend it. It's his fucking thing. What am I going to tell him, dude? I just told him I disagree,
Tell
and I
him.
think it's useless, and that it gives people like you a reason to try to discredit the whole thing. And he,
Right.
chose
Tell
to
him that you
whatever.
can put any occlusion time you like, because the J factor will bring it exactly back in line.
He's not doing that though. He's adjusting the azimuth to
Yes,
give the
he is.
globe Earth prediction down to 0. So he aligns it precisely with globe Earth. If you look at it, it
Right.
moves globe Earth much closer than you've ever been. But simultaneously, inadvertently, it makes all the flat Earth elevation misses almost precisely dead hits. So that's what his point
Right.
was.
Did that not set off alarm bells for you?
If you turn it off, the raw data looks totally right. We're within 50 meters up and down, give or take the whole way across.
Do you know why it doesn't set off too much of alarm bells? Because the elevation difference is never going to be close to ours, because you guys are using the refracted angle.
You're getting results with the J value, right? Where the
we're not.
We're specifically not.
Right. With the J value on, you're getting results that match down purely because of the accuracy down to the second of time, right? Down to like a meter of difference, whatever it happens to be, work out to, right? Did that not do something in your head saying, holy shit, this matches too perfectly?
Whether or not it did or not doesn't matter, because we don't use it anymore, and there's no need to like who cares, right? If it's not part of the
So Mike's
conversation,
not going to bring it up again.
If it's not, he may bring it up again. He's his own man. We've discussed it many times and say it at the last couple of Cell Theo updates. None of us can reproduce it physically, so we're not going to use it as part of the argument. You can specifically toggle it off. We don't care. I'm not gonna argue police his thing, dude. If you want to do that, that's your own thing. Like new subject.
I'll have one
bro.
more say, then I'll go.
No,
I'll say one more thing, and then I got to go anyway. My video shows that the actual occlusion time, if you have the J value on, you can put in anything you like in that field. Doesn't matter what time the star gets occluded, you'll get perfect FE results. Therefore, you may as well stay at home. That is
it's not needed. Hey, so I just tagged you in a post. I posted all the data with no J value. Take a look at that. You got your geometric, which is the red one on top, which is that's your refracted, terrestrially refracted geometric Earth curve drop corrected globe prediction. And then on the yellow is just the geometric Earth curve. You can tell how both of them are off. No J value required.
Right, so Pikes Peak, you're getting off by 50 meters. My half an arc minute, what does that equate to?
What do you mean half an arc minute? You're not. You can't let us compare.
Off by 50 meters. The sky moves at what is it, 30 meters a second? So
he's disagreeing with the 232 being the actual occluded time.
Right.
He's bringing it back
So
to on this example.
Your flat Earth prediction.
What?
Your flat Earth prediction is off by 50 meters or so for Pikes Peak. Mine's off by like 6 or 7 for the globe.
No, it's not.
What's my position? That's
219 is your angle that you gave to me. The tangent of 219 times the distance does not give you. It's 200 meters off, dude. So
so drop in refraction, correct? Yep.
No, you've already corrected for dropping. Correct. That's how you got the 219. You specifically corrected for celestial, terrestrial, and geometric Earth curve already. That's how you arrived at 219. This
is another example of you going 1 + 2 = 3, 3 - 2 = 1. Given that I used drop and refraction to get my 219, then if I'm going to reverse it back, I need to account for it. What?
No, you're saying that's the time that it was.
Yes.
That's the
Holy
prediction.
shit.
That's
Holy
shit. You said it's there. So that's what you're
holy shit.
Real quick, Ruhiv, that's not what that is at all. The physical occlusion timing and a distance are like the two things, right? So that's not. It's an entirely separate thing. It's not the way you just try to frame it. It's an entirely separate analysis because the occlusion process is physical.
We're talking about my globe prediction, right? For me to infer a elevation, right? I've got to do the trig. I've got to take off drop and refraction. That's how I get my elevation, and it's going to be 4,300 plus or minus 5 or 6 or whatever. Does that not make sense? Like I don't understand how that doesn't make sense.
I stopped listening, to be honest.
Come on, Jeff.
Sounds like he's trying to refract his wave both ways to get it
Yeah, yeah.
closer.
Well,
Just
no, you
trying to.
can't. Your prediction is your prediction. When we say we have mutually exclusive predictions, and you spoke for 93 comments on your video to have me go from 217 to 219, you were so precise. Told me how to correct for terrestrial refraction. Even if we do that, you're still wrong because the occlusion happened at 232. That's the correct angle
No, it
from the
didn't.
mountain, which is the process. If you go to
And
the mountain,
again,
It didn't.
which is the process,
how
it's
many
232.
times?
Yo,
So
How many
what,
times have I shown you the screenshot from Stellarium, Shane?
No, nobody
bro?
cares what you observe the angle to
There you
be
go.
from somewhere else who's not at the mountain. No,
From
nobody
observe the angle
cares.
to be from where the observer
There's
was.
no
Listen,
angle to
Wow.
be observed. They only observe the time. The time is the observation.
Yeah, I
That's it.
set the time.
Yeah,
I
so
set
your
the time in
angle is
Stellarium.
219. You can't say your angle is not that. The actual occlusion time is 232. That's the
No,
comparison
the
point.
actual
That's
occlusion
the
time is
stellarium.
18:27:25.
No, we use stellarium at the mountain to predict the time.
Right.
That's what Jesse Sheet is comparing
that
everything else to.
Ruhif,
Your man, my position.
Ruhif, that discrepancy is the point.
The half an arc minute. What?
No, dude, the fact that the star gets occluded at 231 at the peak and you
No, it
no
doesn't.
longer see it.
232.
It gets
yeah.
occluded at 18:27:25 time.
No, it doesn't. That's retarded.
What?
You have to
What?
be.
Sorry,
at
what
the
time
peak.
does it get occluded, Shane? What time does it get
Where are
occluded?
you
I don't know.
getting
I
the
didn't.
number
I
at?
didn't write down the time.
18:27:25.
Fine.
If
It's
you
still
use stellarium
232.
correctly, you get an angle of 218 and a
No,
half.
you have to be at the mountain. That's the comparison
Well,
point.
that's
For all
retarded.
the other every observation in Jesse's sheet that he's trying to compare. The observation that you just brought up at Bryn Mountain was using this exact method. Dude, you can't say that
Dude,
you're not
that's
comparing it to that
bro.
observation point. At any given point.
Ruhif, that's why I was saying earlier he used the true geometric position at the location for the alignment.
Yes, exactly.
He's
That's the mutual.
testing. He's testing your rubbish. Do you not understand that?
Do you understand that whether or not he's testing it or not, the occlusion timing is the occlusion timing? Like,
Yep, we all
you
agree on
can. Okay, then why are you trying to
18,
change it
27,
to a different measurement, dude?
I'm not. The occlusion happened at 18:27:25.
232.
UTC minus 7. We all agree on that.
No, nobody agrees. Nobody agrees on that.
What?
But you. No.
Literally nobody's
Sorry,
agreeing with you on that.
Nobody agrees. It's 232.
What? It's in every spreadsheet. The occlusion time 18:27:25.
So
Stellarium at the mountain is 232.
lads, as I said earlier, this is the exact flip flop and the contradiction that they have to do, and they'll never acknowledge
Do I
it.
need to screen share?
He's literally at the observer location now, referencing refraction on, but from the Blend Mountain, you have to use refraction off and be aligned with the peak.
Hang on.
Yikes.
Are you guys disagreeing with the occlusion time?
You are.
Occlusion time at
No, I'm not.
Stellarium at the mountain.
18:27:25.
You are, and
Is
you're
that the
arguing
correct time?
rhetorically, trying to confuse everyone.
Yeah. It's
No,
over.
Shane said
That's
we
fine.
disagree on the occlusion time. I don't.
No.
18:27:25.
No.
Is that
For
the correct time?
all the rest of the observations, we're using
So,
the stellarium prediction
Ruhif,
at the peak for the elevation.
where's the true position of the star at that time? That's all we even care about to begin with.
206, I think.
Okay,
Something like
that's
that. Yeah,
for
206.
So check this out. For internal consistency, right? All we're referencing always under every circumstance is the true position of the star and the peak alignment. If those two are alignment and suddenly we can't see the star, we can draw this geometric implication. I understand what you're saying, but your method and analysis is not even the same as ours. It's making and when we listen, this is the important part. When we backwards derive the distance based off of the occlusion timing, we get the elevation more correctly predicted for a flat Earth.
Except for Jesse's, right?
Yes, because it was specifically made where. So this is the thing. So this is the thing. Even with him trying to cook it, right? He used the true position.
Not cooking. It's not cooking, Alan.
Will you listen? Okay,
Oh,
going to a specific place where the expected angular globe drop is the same as the refraction correction that's called cherry picking. Because here's the thing, you can do this anywhere. All you need to do is go anywhere, any distance, any peak, and just record your lat long and the lat long of the peak. You don't need to make a simulator to find a ratio based off of an observer at sea level to get the most refraction. But that's secondary to the point. The real point here is that the true geometric position was used in that.
So ignoring Jesse's observation is not
so
cherry picking, according to you.
No, we're not ignoring
So
it.
it doesn't work for Jesse's then, right?
Listen to me. We're not ignoring it at all. When you backwards derive the distance off of the occlusion timing, consistent with our method, it shows that the elevation doesn't correspond to what the globe predicts.
Not to mention, none of you can agree on the same prediction, and there is no arbiter to confirm the globe prediction for this. You all have different arc minutes. Remember that. Just saying.
Hold on. Shane said, sorry, Alan said that it doesn't agree with what the globe predicts. That's your straw man globe prediction.
No,
right?
that's a triangle, bro.
Yeah, it's wrong.
That's a triangle based. That's a triangle based off of occlusion timings. There should be no geometric implication with the true position in a star and an observer X amount of distance away in an occlusion timing. The fact that we could use that to backwards derive the distance to an observer based off of the time and the elevation shows that like that's mutually exclusive to us. You need to know where the observer's at and look at the time and then add refraction. That's a post-diction. Like you've been the internal consistency of your model has been tested externally, and like this is why you're not accepting it, because it shows that there's no actual Earth curvature and the objects are always above us. That the stars are coplanar with us.
So when I said it matches everything except for Jesse's prediction, Jesse's observation, and you said, but that didn't match the globe, right? The question is, does it work with the celestial theodolite? The answer is no. It's off by 16 arc minutes. Why did you say instead, it doesn't match our shithouse globe prediction? Why can't you say it doesn't work with the celestial theodolite?
Because even being off, it still derives a higher elevation than what the globe predicts.
No, that's your straw man globe prediction.
That's right? Just a triangle, bro.
The tangent of the angle you just gave me and worked out. So whatever.
How come it backwards derives to the distance, dude? If it was fucked up and didn't work right, the distance would be off on it.
So you went the arctan of 640, which is the delta height, divided by 41 kilometers, and you got 54 arc minutes. Yeah.
Yep.
And then you went 54 arc minutes, tangent of that, times 41 kilometers, and fucking magically you get the same answer that you started with. Magic. Right? That's what you did, Shane.
Well, our prediction for the angle of occlusion was that, right? So the actual elevation angle that we would have to have the mountain at for that to happen.
But
that's
the star
that's
angle.
Comparing.
The star angle is 38 arc minutes, not 54.
That's true. But your
right.
prediction
So it doesn't work.
Well, no, we said the timing is closer to the globe. But if you take the triangle and we try to predict the elevation, you're 47 or 41 or 44 arc minutes, because remember there's 3 different predictions and nobody can agree. Either one of those would all disagree to a lower elevation, because once you try to get a refracted height of a triangle, it'll always be lower because your occlusion time is wrong, because occlusions are physical, dude. There you go. That's the whole point.
But for me to come up with a globe prediction, right, I have to do the delta height, I have to do the trig, I have to take off the
you understand, you want to add it in and then add it back out, but that's retarded.
Riff, the backwards deriving the elevation as part of the physical occlusion, like, you know, being consistent with the methodology itself, is exactly why this was implemented, because the angles get ambiguous at the horizon, right? Especially when they're because there's a lot of refraction and compression.
You know what I'm going to say. Pointless.
Yeah, it's your thing.
You guys claim to have eliminated refraction.
To discuss observations at ground level below.
Yes, Ruhif, when an object's no longer visible, it's no longer being refracted, right?
Right.
Okay, so like what time was it refracted? Because time equals angle. So it's like what happened? So what's that?
There's no refract that the curved path of light is not reaching you, right?
Correct. Right. And that and all we're concerned is like what time does it happen to be when that happens? That's all we're concerned about. So like when we say
18, 27, 25, if I speak.
God, you're just gonna keep repeating his nonsense interpretation of it.
Well, that's the actual time of occlusion for the canonical example.
No. The time is actually 2:32. We've been over.
No, that's not a time. That's an angle, Shane. That's an angle.
Angles equal time. Remember?
Which is
what is the time that it occluded? time is 18, 27, 25. You guys do some stupid shit to come up with an angle. I do
No.
an actual globe prediction.
Why are you not even saying what you're doing? You're saying you're moving the observer back to the Heffron house to accommodate the distance back
Yes.
to the observer so that you can say the occlusion that happened at a different time. When we say we
I'm-
compare it to stellarium for an arbiter, like we just went over how you guys, for this particular observation, the 3 globe predictions are all different because it's so hard to use your refraction to predict anything coherent at this level that all 3 of us doing your method came to 3 different predictions, okay?
Yeah,
Now,
we will sort that
okay.
out.
Okay,
We'll get to the bottom of
for
that.
sure, but that's where we're at right now. Now, for every other example, we know that stellarium at the mountaintop using refraction off gives the correct angle for what we know as the true angle at the time of occlusion. That's the true position. That's what we're using stellarium for. That's from the Nautical Almanac. For you to, let's say that actually that's not the time. It's actually a totally different time when I move the observer 50 kilometers away. It's retarded, dude.
To
Everyone
where the
agrees.
observer is.
Well, the whole
To where the
whole
observer
method-
actually made the observation from.
The whole method is
Jesus.
to compare it to stellarium at that point. What was the
Oh,
point
man.
of a delta height, of a delta comparison? He's got a whole column here for flat Earth predicted stellarium measure with meters on how the predicted heights work. He's following this method for every single observation, even the one that you keep trying to bring up, where yes, the timing is closer. So are you saying that the timing isn't closer on Jesse's Bryn Mountain?
I don't know Jesse's spreadsheet. Right. All I know is that they
No.
all match the globe, and the celestial theodolite is all over. The
What? I don't know his spreadsheet, but I know they all match the globe. Dude, Ruhif, did you say
I've got
you
all
had
the
to get out of
data.
here? Did you say you were about to die,
I've got
bro?
all the data,
Can we-
Shane. I
can
don't
we-
have Jesse's
can-
spreadsheet.
Can we
Yeah,
call
the
it a
data.
night, lads, and say that you're doing a different analysis, trying to like invalidate the methodology, whereas we're just raw dogging triangles and deriving elevation angles, hitting up our boy Pythagoras'
on.
theorem.
Consistently
Have I
repeatable
got
by our
the
boys.
methodology wrong?
Yes.
I don't even
Okay,
think you're really
so-
following the premise of the whole experiment there, Ruhif.
Hang on.
You're trying
Apparently,
to
I've got the whole
now
method
you're just
wrong.
trying to get make everything match up to a globe when that's not even the point of this.
No. Do I have the method correct? Right. We move the observer to the mountain and get the unrefracted angle to the star,
Which
and
is
that's
what,
meant to match
232,
the raw
right?
flat Earth angle.
232.
233. Yeah.
Oh, okay. No, 232.51. Whatever.
Yeah. And that's 2 arc minutes off the raw flat Earth angle of 231. Yeah.
1-ish, 1.5, I think. Yeah.
Yeah. Sure. So with Jesse's, right, the raw trig angle is 54 arc minutes, but if I go and put the observer on the peak, the angle to the star is 38 arc minutes. So it's wrong by 16 arc minutes.
Yeah. But Jesse's prediction for Pikes
It doesn't
Peak
work.
is 217, by the way, not 219. So again, the globe
No.
prediction is different. Yes, I'm looking at a spreadsheet, Mr. I've never looked at his
I
fucking
guarantee
spreadsheet.
you, Jesse's angle is
217,
219.
217, 41.88. Here, let me send you a screenshot. Now, I did rename it to Jesse Path of Horseshit, but just know that most of it is his. All right.
I guarantee you, Jesse's angle to the mountain, Pikes Peak, will be 219.
It's not.
Bro, he's
Well,
about to
that
send you,
doesn't
he's
matter.
about to send you a screenshot of it.
There you go.
Right? From his replication of the celestial theodolite for the globe, right? He knows that it's bullshit. If you ask him what his actual prediction for the globe is, he will say 219.
Well, you know,
I'm
that'd
running
be
out
really
of testicles
weird.
to bet. Okay.
That'd be really weird if he didn't put that in his spreadsheet, though, right? So, I mean, just saying that's not included.
Well,
if
he
he has
just-
like a secret wish that he's holding on to himself that he didn't want to share, then maybe that would be valid. But it's not
No,
fucking
well,
here. So
we can
I
ask
don't know
him.
what to tell you. I don't care.
We can ask him.
Whatever,
Yeah.
dude.
And
Can you send me the
what could I
screenshot
bet?
as well?
Yeah, I tagged. Yeah, hold on. I'll just send it to you.
We'll just go ahead and post it. So now that we're all on the same page. All right, go ahead. Do you see that? Do you see that, Ruhif?
I do.
Okay. So now that you know.
Right, but what is he actually doing? What is his actual prediction?
It says
Is
globe Earth
he doing it with the
prediction
celestial
in
theodolite?
globe Earth prediction in degrees. He's doing
Bro,
Right, has he added in refraction?
yes,
Bro.
yes, refraction, celestial,
show me
and
refraction in that.
terrestrial. My God.
Go one column to the left. What's in there?
Earth prediction, drop in meters. What do you mean?
The globe Earth prediction degrees.
Yeah.
What's in there?
Well, I added that. I'm converting the decimal degrees on the left to degrees, minutes, and seconds because that's what I'm comfortable looking at to compare.
So hang on, you added the column that you're saying is Jesse's?
No, globe degrees I added. His column says globe Earth prediction, comma degrees, which is decimal.
Okay.
And mine converts it
Right.
to
So
degrees,
what's in
minutes,
that?
and seconds.
What's in that column?
Degrees, arctan, delta height, overrun.
Right. So no refraction.
That's globe Earth prediction in degrees.
Does it have refraction in it?
Yes.
Are you sure? It doesn't sound like it.
Yes. Yes.
It doesn't sound like it, Shane.
Well, you said that his spreadsheet had 219 and it doesn't. So this is what I'm showing you.
No, I said his globe prediction is 219. I haven't got his spreadsheet.
His column entitled globe prediction says
Right.
otherwise. So maybe you thought
but
that maybe
is
he made a
including
mistake. Maybe he has a different version out there that he didn't share with everyone.
Whether or
Maybe
not he's
didn't
including
inside.
refraction, my dude, it doesn't say that. It just says the 219 value in the spreadsheet or 217 or whatever.
Right.
So
how about we just ask Jesse?
So you just said that it was going to say a different value, even though you haven't looked at it, et cetera, et cetera. We just
boldly claimed it with.
We just sent you a screenshot of it with showing a different value, and you're talking about how he must have meant a different thing. Like, dude, I'm so tired of this.
Right. Okay. If we ask Jesse,
nah, dog. What's it say in the screenshot, dude? This is fucking ridiculous, Ruhif.
All right.
What are you,
fun, buddy?
Come on, don't take it here, dude. It's been cordial. Let's wrap it up,
it's been
man.
right, actually. Yeah. So
I'm sure
okay,
Jesse
so to
can
settle
change
that,
it
we'll
to
ask Jesse what his actual
219. He
prediction is.
changed other stuff.
Next time it'll be it was never 217. It's always been 219, and we're retarded for saying otherwise. They're gonna like in 1984
I
memory.
guarantee you I could go back in my DMs with him and he'll say 219.
That says 217 though, man.
I don't disagree that you guys
have this spreadsheet. I don't know what he's doing there.
Even still, what angle was it included at, Shane? Corresponding to the time, because time equals angle.
232. 51.
Oh no way!
Yeah,
no way. So still
no
not
way.
even their time.
I've only showed you screenshots from Stellarium 218.5. Oh no!
You took your own screenshots from a different position. It's a totally invalid way to.
I think we're done. Yeah, I took screenshots from where the observation was made. You know, that's all it comes down to.
Well,
all right, it has been fun.
We should call it the retarded Ruhif method, and then we can compare that to the Heffron method, right? And then there wouldn't be so much confusion.
Anyway, yes, it's been relatively cordial, which is
it's
nice.
always fun, dude. Thank you for not being Jesse. That's my main contention at this point. I'm just so sick of talking to Jesse. All right, later, dude.
I agree with that premise.
I'm so sick of Jesse.
Oh.
Otherwise, this has been
dude,
fun.
the dude's a big fat liar, and he misrepresented. I mean, seriously, he's not worth it.
Dude, this has been really fun, though. I think we got.
Dude was
about
asking me if I wanted to bet body parts. Like
who?
Ruhif. So as noted, like they'll never acknowledge the using the true position on that one, and they'll just try and obfuscate and talk about the refracted position. So moving the observer back to that location doesn't help at all. Our method is consistent. We're using the true position and when it intersects with a peak, and we could backwards derive the distance off of it using the time of occlusion or the angle and the elevation.
I can't believe he actually used the argument. I don't know how you're wrong, but I know you're wrong.
I don't know the data, but I know Jesse, and he wouldn't be wrong.
He wouldn't be wrong. I got Jesse in my back pocket.
Dude, they go over it all day on Telegram together, and like to act like he doesn't know it, and like all this is anyway, guys, this is one of the most powerful arguments because it's so easy to understand. Like they can't even engage with it on the face of it. They have to like invent an entirely new method because when you externally test their internally consistent system, there's no Earth curvature. The timings would be different. Guys, I would be arguing for globe Earth if we backwards derived the elevation and it came out with the globe. That would only be possible if it was physically getting lower than you. They cannot acknowledge that at all. It's very, very straightforward, dude.
Just the amount of damage control you see Jesse doing by lying through his teeth so vehemently, like just why would someone need to do that? And then you notice no one else has ever put forth any sort of refutation or argument against this. And Ruhiv's whole thing about a fudge factory just got summarily destroyed. So there is no really other objection. That's why everyone is dependent on Jesse. That's why if Jesse just lies and obfuscates and says things, people just point to Jesse and they're like, oh, he solved it. But as we see, he solved nothing. It's detrimental and hugely destroys the globe.
And he's a big fat liar.
So, am I hearing this right? They have one observation that's really close to the horizon, and that's their whole case.
Yeah, he's trying to invalidate the whole thing.
Yeah.
Ruhip, the king of refraction, the king of I don't want to talk about observations at ground level because I'll just argue that I can see my own ass because of refraction is like infinitely fault. Literally has said that to me. And now all of a sudden he's like, this observation invalidates your method. And it's like a half a degree above the horizon where it's the most like, come on.
Less than half a degree. But
It's tiny. It's a tiny it's a little hill.
Yeah. But on top of that, to even get the thing to line up, the true position was used, which is like if they were going to be consistent with their explanation, they would have to use the apparent, meaning they would get a timing that would be sooner because the star would be higher because it's
Which they do.
refracted up.
Which they do. And again, we got 47 arc minutes doing our method, our consistently repeatable method. Jesse got 41 in his spreadsheet that Ruhip hadn't seen. And then Ruhip on the spot calculated for himself a sparkling 44. So the globe, whatever they're doing, it's different for every fucking time. And they can just make shit up on the spot and it doesn't matter. No one can check them because there's no certified globe prediction for this that we can actually confirm. So there you go.
We're literally checking, we're referencing the globe. You can backwards derive all the occlusion timings to correspond to where the true position was with respect to the mountain peak at the time of occlusion. So you can double check our work. That's another significant point.
Yeah, they're just making shit up in Wild West land with no one to double check anything. If everyone can have their own prediction, like who gives a fuck? I guess I can see the point. Like what?
And keep
Got to
in
be
mind,
consistent with something.
And keep in mind the relationship with Jesse's is only angular, right? When you backwards derive the elevation for the physical occlusion, it's not the time that they predict. I mean, I'm sorry, it's not the elevation is higher for us. We're closer to what the elevation is. Now, and that specific peak, like I said, there's like you can go to Google and just Google it. You'll get 4 different elevations for it. So like I respect that I respect that they used an official source like the FAA thing and then came up with a metric based off of their camera lens and all that. Like for real, that's like a valid thing or whatever. But then like dude, that's fucking it, like that's the same thing that's the same thing that Mike was doing and they were like, no, you can't do that. You might as well so when he's like, you might as well stay in your basement or whatever, it's like, well, you might as well stay in your basement if you're gonna come up with a method to manually adjust the elevation per occlusion or emergence. And it's like that yeah.
Do you have a question there, Jonathan? You still with us? I saw your hand up.
Yeah, if anyone has any questions or whatever, because I'm about to hop off here.
Yeah, I gotta go walk the dog and stuff.
But if anyone has any questions before we dip.
You there, I did, and I forgot it.
Can you possibly send a version of that that's more readable? I can read it mostly, but it's kind of pixelated.
Of what? The spreadsheet?
Yeah, that last item in the jumbo.
Oh, dude, is that Jonathan, the guy that used to have the other avatar?
Yeah.
Oh, what's up, dude? You should come to Aether Cosmology Discord, bro.
I have not really used Discord hardly at all.
Oh, we'll teach you all about it. It's really simple to use once you use it 500 times and repeatedly or whatever.
I just stick with these Aether Cos.
I mean, Discord is so much better than Twitter. It's ridiculous.
Dude,
Yeah.
Rudek just threatened us with a screen share that it's actually impossible on this platform, and he has no idea. He was like, "Yeah, I'll show you," and I was like, "Oh no, no one can show anyone anything actually."
I have a quick
Turns
question
out.
before you go. I keep dropping in and I have to duck out and stuff. I keep missing it. I'm not around what it is that you're talking about. Could you briefly explain it?
Yeah.
Hopefully,
Yeah.
so I can understand what it is you're talking about.
Yeah, real quick. Do you live in Australia or New Zealand, Roundhound? Is
I live in Australia.
Is there an Australian accent I detect, mate?
That's London, bro.
Oh, whatever, dude. Well, whatever. You guys get it.
You
So,
start with a mate and end with a fuckwit, and you should be right.
All right. Oh, so do you have the ability to record stars at night or nah?
To what level? Like track them or just stick a camera on them? No, actually, no, I don't.
Oh, okay. That sucks. Well, so the basic premise of this is, right, you have the ability to record stars and there's a mountain peak somewhere away, some distance away, right? So you get your GPS location, you get your lat long coordinates, right? And then you get the coordinates to that peak and you set up your device and you just record when stars get occluded by the mountain peak or when they emerge, depending on whether or not you're facing east or west. And then you go into Stellarium and look up where the true positions of those stars were. And the true positions of the stars will be intersected with the mountain peak when you end up looking it up. And you could, once you have the distance to the peak in your locations, right, you can start to backwards derive, or you could figure out what the predictions for a globe would be for the occlusion timing based off of its physical elevation with respect to that true position. So just using plane trigonometry, you can determine what the flat Earth prediction would be for that peak, assuming that there's no elevation drop, and then you could also account for what the globe would predict for it to be, and that timing difference, or I'm sorry, that angle difference is going to correspond to a different time because the whole globe model is based off of time and where the stars are at, because time corresponds to angle. So there should be no geometric relationship with the true position of the star and the occlusion timing if the Earth, unless that intersection is physical. So with that, that time is going to correspond to an angle, and from that we can backwards derive the elevation that caused it.
Occlusion times prove flat Earth by aggregate elevation predictions. Dude, the AI was giving us some pretty funny titles, dude. Astronomer's plumb bob. Determining shape of the Earth.
Okay, I think I understand what you mean, though. Immediately, the first thing that would jump out of my head, though, is whether the Earth is round or flat. When I look out and see that mountain peak, it's at whatever angle from me.
Right. No,
regardless of.
We completely agree. And our position is that curvature and things missing is like an optical effect, an optical phenomenon, whereas it's been asserted that there's physical curvature and then that things are refracted up or whatever, or dropped over distance, whereas we're saying it's just optically compressed and appears smaller because it's further away, those kinds of things. And so the reason that this is significant is because occlusion timings are physical. So in other words, when the light source intersects with a physical object in between an observer, that's when they're no longer going to see it. Now, when there's refraction between that light source and the object between the observer, there's still going to be, or I'm sorry, that's going to change the occlusion timing because the angle is going to change for where the physical intersection is going to occur. But once that occurs, it's no longer visible for the observer. And when we're dealing with stars, they're about 0.5, or I'm sorry, they're about 1 arc minute in size on the telescope. So once they get below a peak, they're not going to be like refracted up 25-30 arc seconds. That's preposterous. And so I'm not saying that the time's going to be like exact 1-to-1, but when the stars get occluded, it never matches what the globe predicts, except for in a specific instance. But like I said, when you backwards derive the elevation based off of the actual occlusion timing, that elevation is always closer to what a flat Earth would predict for the physical elevation. And
Okay,
you're free to disagree with the premise or whatever, like Rid
I got
does.
I've only just this is the first time I've heard it, so no, I'm not going to disagree at all until I've looked up and I think I understand it, but I'll go and make sure of that before I poo-poo you.
You're on Discord, aren't you? As well, I think I've seen you on Earth Awakenings, haven't I?
What's Earth Awakenings? I just
Is it
joined
Discord server?
Indio's. I'm not sure. I was on one that had Nathan Oakley in it, and
No, don't go there.
I don't know. I just wanted to freaking rip my teeth out, so I left that one, and then I just joined Indio's this morning.
Oh, nice. Yeah, I would avoid the other one, but and Indio's probably a good place. I haven't been there, but Indio's a good lad. But
Also, just post.
Indio's in the audience.
I know. I wish we'd come up. We got we're gonna do an update for the celestial theodolite on Monday on Discord. So if you're around 8 p.m. Eastern time, whatever that time will be in Australia, mate, you're welcome to join. You could learn more about the process. We'll do some more in depth because I'll be screen sharing it, so you can watch your videos and stuff and kind of get the process a little bit better.
Yeah, regardless of where you are, it's pretty much always the other side of the clock for Australia. We are so freaking far from everybody. It's annoying.
Right.
Well, that was a good time, dude. That was fun. Glad Ruhif showed up and we could dissect all his bullshit. Because he just made a video and people are like, Ruhif took care of it. It was like, oh, did he? Did he, though?
Well, while there's a pause here, I remember what I wanted to say. And it's mostly for the audience, people that if you haven't gone to Discord and listened to Dr. Mike talk about this and take questions on it, which he's done from the very beginning, I think, like 12 or 13 times now, something like that. You had Bruhif come in here tonight and use one singular observation really close to the horizon. Everything about it's questionable, debatable. And he wants that one sighting to overturn everything. And then you have the polar opposite with Dr. Mike, who has a multitude of observations and he's repeating them, he's putting them in the spreadsheets. Anybody can look at it, anybody can analyze it, anybody can check his work. And he doesn't even say, with all the observations that he has, that, hey, that's it. That's it. It's over. No, he says we need a lot more observations. Even though everything is saying flat right now, I mean, it's pretty awesome. But even he's saying we need more observations. So that's the two personalities contrasted right there. One person wants to take a singular observation that's questionable at best and overturn everything. And the other person has a multitude of observations that all swings towards the flat earth. And he will still not declare it definitive because he doesn't think there's enough data. That tells you a lot about the two personalities right there.
And I don't think he set it up right anyway.
Don't
Well,
look
I
over
mean, it
there.
was added, wasn't it? Didn't I hear somebody say that it was added to the spreadsheet, the observation?
Yeah, it's in the data and everything. We took it on board. Even after all the shit I gave him and all the things I pointed out, I was like, but we'll just take your word for it, and you're still fucking wrong. Like, that was the whole point. After pointing out everything that didn't work. And he's trying to say that because of that, because of the horizon man, the never discuss any observations between flat and globe near the horizon because I'll always win because refraction is infinite guy, Mr. Ruhif, says that one observation within that very same opacity deck where he would claim infinite refraction for any terrestrial observation, that he actually made a celestial observation that invalidates our method. That was his premise. So that's crazy.
Yeah, that is nuts. And I was glad to hear you explain it that way too, because man, y'all get to talking numbers and it's easy to get lost. And I have to grab the things that I can. And that right there explained a lot, especially when you start pointing out his previous position and now his newfound position because, the methodology.
Dude, he was the king of refraction. I joke every time you say 7/6R, Ruhif would appear, right? That was a thing.
He was the reason I never cared about refraction or long distance observations, because you can, like, it's just unlimited refraction and it seemed like the most uninteresting thing ever. But it turned out to be, like, super fascinating. And like once you have a way to check and verify it externally, it's a wrap.
And then I'll immediately change the goalposts and say that it happened not at the time that we're using for all the other verification.
Dude,
and then I'm gonna make up my own prediction that doesn't agree with anyone, that nobody can double check against anything. And then I'm gonna claim you strawman my unverifiable position. I'm sorry, dude. That's great. That's just desperate. Whatever.
and keep in mind the actual measurement that Jesse made was consistent with our physical methodology of aligning the true position with the expected elevation of the peak.
Nope.
Like, so the whole, like, but when I go to Heffron's house and use the refracted position, that's off the table now. That's literally not even a position, guys. They can only argue it rhetorically.
How can you argue like with Pikes Peak? And I use that one because I kind of remember the distance of 50.7 kilometers to the mountain peak. So how can you use Pikes Peak, the peak, as your celestial theodolite, your crosshairs,
So our premise.
and then turn
Oh, sorry.
around and try and say, after you use that to occlude the star, to try and say, oh, well, I want to get the position of the star from where I was standing. That doesn't make sense to me.
It was like, well, it
It
doesn't
was
work this
occluded
way.
by the mountain.
Yeah, I'm gonna go back to the other way. Does nobody mind? I'm just gonna change the rules real quick. I don't like this.
Yeah, our premise is that the globe is made up from refraction corrections, and he's like, yo, let me move the observer so I can get this refraction correction.
Well, that pretty much is their argument. They're trying to get refraction in there every chance they can. Because at one point, if I'm not mistaken, he was arguing to put terrestrial and celestial refraction in with the position of the mountain peak. And then when he got the star's actual position, he then wanted to apply refraction to that also to get it down lower.
And it still doesn't work because he did that, right? The actual globe prediction for Pikes Peak is 2 degrees 17 arc minutes. Ruhif argued with me for 7 hours in the comments of his video to get me to have him to accept actually it's 2 degrees 19 minutes because he adds 2 degrees for terrestrial refraction, which is again retarded and against all the rules, but he added it anyway, and that still doesn't help him because the actual occlusion happened at 2:32. And then confronted with this, he was like, "Well, no, it happened actually at my time. If you use stellarium correctly," he starts to say out of nowhere, right? He's just like, wait, what? All of a sudden, we're not using the occlusion at the mountain peak like we do for the other 42 observations. We're going to do this method when it doesn't agree and matches our prediction perfectly. We're going to change everything. That's the most, like, transparent line of bullshit I've ever seen. I'm trying to pull, to be honest.
What you got, Jonathan? Yo, Jonathan, you there?
Sorry for the delay. I was very carefully shifting my baby so as not to wake her. Yeah, I find all this very interesting. I kind of want to set up an experiment somewhere near my home, but unfortunately, I live where the glaciers scraped everything flat. So not a lot of mountains around here. So, but
Unfortunate.
the Smokies are not too far away. But I don't know that there's trees on those mountains, and I don't like the fact that that adds some variation, I guess, some uncertainty in the appearance of any given peak. I'd much prefer like a rocky peak, obviously, but the only time I've ever been around those kind of mountains was for a business trip, and that's no fun because then you don't get to go out and have any fun. You're trapped in a warehouse or something. So, woe is me. But anyway, if I ever had the chance, I'd enjoy doing an experiment on
I'm
celestial
calling.
theodolite.
I'm calling bullshit. Every parent knows that when you've got something personally enjoyable to do, you cannot keep a baby asleep.
Well, she's still asleep so far.
All right, lads. Oh, yo, is that Mr. Xavier over there with his hand up?
Yeah, we got
Mr.
Mr.
Xavier's got his
Dude, I've
hand
been
up.
waiting to talk to you all night, bro.
Yeah. What's up, brother? Now, I just had a quick question, bro. I'm sure Ruhif understands that with the statistical data, there's something that we're trying to figure out, right? As looked up on the NAS when studying Pikes Peak, as Ken talked about, and this goes for all the observations. Isn't there a value that's obtained with the statistical data, of the probability of obtaining results as extreme or more than what's observed in these studies? And that's assuming the null hypothesis is true, right? That Earth isn't flat, and also known as a p-value. Did he go ahead and map that out in some type of statistical formula or anything like that, based on these observations? I don't think he has. I mean, I'm
Not,
surprised he hasn't
not that
already.
I'm aware of.
Right. I mean, that's very curious, don't you think? I mean, he's trying to nullify the null hypothesis. I would think that would be really important.
Yeah, but what if the goal is just to say enough bullshit that confuse people? Like, what if that's the goal?
True. Then yeah, fuck all that p-value bullshit. Yeah. Fair point.
Anybody can have an ego, and if you have an ego, then you can be caught in a moment where you're doing exactly that, no matter what side you're on.
But like, I don't know why I wouldn't avidly go to lie about something to different groups and tell different stories and whatever I can get away with to actively try and discredit a thing that I secretly know is valid, right? That's sneaky, underhanded bitch behavior, right? Like, I think we can all agree at that.
That's why we keep the ABC policy in play. Always be steel manning.
And listening, for Christ's sakes. Not just waiting
The
to speak.
ABC.
Dude. Jesse was like, I don't know, I wasn't listening. He just mumbles a bit when he was talking to Dr. Heffron one day. We were like, what? He just outlined the whole procedure in 14 seconds flat in the most concise way I've ever heard it described. And you were like, well, okay, Jesse, that's enough out of you for today.
All right. Well, thanks for having us on, lads. Was a great discussion. Hope everyone got to learn something and have
I hope so.
fun.
Thanks for coming on in, man. That was great back and forth there.
Thanks for holding it down all day and night, dude.
I want that spreadsheet.
Oh,
Please
yeah.
send it to me.
Yes, will do. And I sent you a DM for with a Discord link. So if you ever want to check out the app and whatever, that'll take you straight to us.
Cool. Do I need a membership or anything, or
Nope.
You just click
Nope.
on it, hit the invite, and you're
Yep,
in.
you just make an
Okay.
account. It'll ask you for your phone number probably.
Okay, easy enough. Cool. Thank you.
Yep.
Monday at 8 Eastern.
Yeah. Yep. All right, lads. See you on Sunday for Man of Stone's Globebusters premiere. He's going to be doing his presentation on shadow sets, where he measured the shadow difference where the globe predicts that there's going to be, the sun's going to be below the horizon. So it's going to create a smaller triangle, and he measured a bigger triangle. What do you know, boys? Triangles win again.
Triangles win again. That's what, 3 Eastern?
Yes. Sunday.
Nice. Nice. Well, I do appreciate you guys stopping in. I am going to be hanging it up myself. It's getting late.
Oh, it is late.
No.
All right, everyone. Thanks for tuning in. We will see you guys on Sunday. And then we'll see you guys on Monday for the Celestial Theodolite update, and then Tuesday for the